Welcome to this lecture on advanced techniques. We are entering the last stages of this XR MOOC. I'm gonna miss it, but I wanted to talk about advanced techniques. So far we've been mostly playing with standard devices, and I'm going to introduce you to a few techniques that I think are important. So standard devices and standard SDKs and everything standard, but in reality, for example, in a lot of my work, I actually build a lot of my own stuff. I actually build custom displays, custom controllers sometimes when necessary, and I wanted to share some of the more advanced techniques here. So we're going to go beyond some of these, and I'll bring in some of these devices that I have here on the left as examples of how to make things more advanced. So let's get started. So here is my overview of the advanced techniques. I'm going to have a block on a few topics that I think are mostly relevant for VR, so procedure generation, redirected walking, and custom controllers I think makes a lot of sense for VR. Then we're going to do a little bit more advanced AR, so 3D reconstruction, object tracking, and custom displays is what I want to talk about here. And then I have a list of topics that are really cross-cutting, so both VR and AR. And remember, this is on advanced techniques. So Michael, why did you put accessibility here under advanced techniques? Well, I wish I didn't have to, but the problem is accessibility is really difficult to do at the moment. We're addressing the topic, I mean, we mentioned it throughout the MOOC, but we're actually really have very limited means to really make the XR stuff very accessible, just because the tools, including Unity and Unreal, are not really accessible. And obviously, like using AR and VR displays, VR is mostly predominantly visual, and then AR, while there are a lot of opportunities in research, it's not really designed with accessibility in mind, most of the AR devices that I know at this stage. So we're going to talk about this. We're going to talk about text input, right? How do you actually get things typed into AR and VR? And collaboration, so multi-user. That's something that I think is very interesting. I'll expand upon this a little bit in my XR research lecture following after this. We're going to talk about adaptive layout and customization, so giving more control to the users or actually the system, being smarter about how to actually adapt the layout of the scene to make it fit the physical environment of the user. Key topic, actually, and not very well addressed in current implementations. Progressive XR, this idea of building adaptivity into the interfaces so that they can actually adapt, an interface can adapt to AR or to VR, depending on the task preference and whatever the user feels like. And so the context could also be a driving factor here. And we're going to talk about this. Finally, mixed reality capture and virtual production. This is a topic that I'm especially interested in at the moment in my research. And also, this is something that you may be aware of from filmmaking. Filmmaking is changing radically, bringing AR, VR techniques into the whole filmmaking world, and I think that's why it is very interesting. It's relevant to us because I've been demoing a lot throughout the MOOC, and I wished I had more of these tools available. You saw a few examples of mixed reality capture and virtual production. I'm going to expand upon that. So this is my brief overview. And now we're going to get started. We're going to jump right in. And so this lecture is really built around some of these concepts. Whenever I have like a really cool demo or video, I'll plug it in. Otherwise, we're going to spend some time looking at some slides that I spent a lot of time actually designing to really get these concepts across. The first one we're going to look at is procedural generation. So you are in this physical world. This is like this is your room, you're looking this way, and then in this world you see virtual content, virtual reality here in blue. So the gray parts are the physical world, okay? And down here, so draw a line between these, down here is actually a, well, kind of like a copy top-down, what you see, so this is top-down view of your headset. So if you walk this way here, you would move that way here, okay? Top-down. Cool. So now that we have established this, let's say you're going to interact with this world and maybe look a little bit, you're coming closer here. I'm going to let you walk in a second, but let's say you are getting here. Well, this idea of procedure generation is we're loading more and more virtual content as you, for example, move or spend more time, could be lazy loading. But the whole idea of procedure generation is as the user explores more of the virtual world while being in the physical world, we can actually add to it. So that's going to be interesting. So we could generate a maze here to have you walk through this. And this actually then brings me to the next concept, which is, well, redirected walking. So redirected walking starts with this impulse. Did you notice? I'm going to go back. I'm going to give you this impulse. That impulse will most likely trigger, it will catch your attention. It's a visual cue, it will catch your attention. It will make you adjust your gaze. And, well, people walk where they look. It's like you drive where you look. And so be careful when you're driving and not looking. And so it's the same here. Okay, so we have a little bit of an impact. And we move this. And now, as we are focused on this, we're actually going to move the table. Did you notice? Just a little bit. I'm clearly exaggerating here. There might be smaller shifts. But anyway, so this shift is really important. Catches the user's attention, adapting their gaze, and walking towards the object. Did you see? Rather than going straight, we actually walked what is more like a circle. So, while the user feels like, wow, I must be like at the end of this physical world now, we actually moved just this way in a circle, and that gives us more virtual space that we can cover in the same physical world. Redirected walking. So if this were, there is actually research that shows that people can feel like they're walking along this corridor, but what they're actually doing is they're walking in a circle. And that is just very interesting. Just a little bit of perceptual tricks here and there. Cool, so redirected walking, we have that. Now we're going to go to custom controllers. We're going to play virtual ping pong here. So it's going to be a ping pong ball. And, well, obviously we can give you normally a virtual reality controller. A lot of these experiences are like that, right? Usually you have some kind of like virtual controller, this one here. And to be honest, this one feels pretty good. So playing ping pong with this is not the worst thing that I've done so far. If it were a different kind of experience, like golf or something, you would feel like, well, this doesn't feel right. So we're gonna explore a little what options we have and how could we build custom controllers. So one thing we could do, and this is often done, is we just give haptic feedback. We give you the illusion of actually holding a racket. Well, we give you the illusion of holding a racket, but we're actually holding is the controller. The controller represented here by this cylinder in the top-down view. So haptic feedback. We could, for example, use the vibration motors that are in most VR controllers to give you that feel whenever you hit the ball or something, we have a little bit of vibration feedback. So make the user feel like they use the real object. But in fact, they're not. They're just using a virtual reality controller. So pedal works quite well. So let's stick with this example. Let's say we remove this. And what we now actually give you is a real physical controller that really matches the shape. It's a custom controller. We actually give you a pedal. Maybe we instrument it in some way so that we can track it, or we do object recognition. I'll talk about this in a few slides as another concept. So this controller now actually has the physical affordances. It really makes the controller look and feel like the real object. It might actually be the real object, but maybe it's battery operated internally. It's a custom controller. You need to think about that. It somehow also needs to communicate with the headset. It probably needs an inertia measurement unit so that you can detect small tilts, and maybe some kind of lights around it so we can track it. This is how most controllers actually work. We can track it visually then. I mean, the computer sees the light. You don't actually see that frequency. Here's a custom controller. It's not as advanced as I just talked about, but this is a project that my student Ruchi and I have been working on. It's an independent study. It was really a cool little project. What we did here was build a custom 3D controller, so that we call it Watch Pod. In fact, what we do is we take a watch, we remove the wristband, we use the touchscreen of that little watch, we put it in this pod, and now as you can see, we are tracking some of the movements, the 3D movements with this controller now. And because we have a touchscreen, we can also go into different modes. Like this is translation mode. Now we can move the cube to the right and to the left. And so we have a combination of the touch display and some other things. We cut this here, and the physical movement of the custom controller. To be honest, just using the inertia measurement unit and the IMU on the smartwatch wasn't really great. Acceleration and gyroscope are, it's really hard to play with those. So building your custom controllers is actually quite a lot of work. And I think this project could be cool. Did you see how we manipulated the A-frame scene? Yeah, so unfortunately Ruchi is now somewhere else in the world, just like many other students, successfully graduated. And this is an independent study that kind of I'm stuck with, but it was a cool idea. And I hope that one day maybe it'll make it into a paper, or maybe into a little bit of a project that we can use in my lab. So this is an example of a custom controller. Now we're going to enter a little bit more AR oriented concepts. I want to talk about 3D reconstruction. Physical world, virtual world, but you're seeing it through an AR headset. Okay? We have a physical table now, not a virtual table. I actually moved it into the real world, if you noticed, and it's represented here by this box. As you walk through this space, what we do is we actually, I mean not we, but the device actually scans the environment, and it does a real-time 3D reconstruction of this. Not only the basic walls and ceilings, no, increasingly we can build denser point clouds. This is then a 3D point cloud that represents this kind of mesh. And so we can also see at least the geometry of this table, what you and I call table. A computer wouldn't be able at this stage, just with 3D reconstruction, spatial mapping, we can't actually call this a table yet. We just have a spatial mesh, so we scan the physical world as a dense 3D point cloud. If you want to call it a table, we need an additional process. It's an important step. We need object recognition, some kind of object segmentation. So recognition, segmentation, classification, so giving it a label. So then we can actually finally call it table. Most devices only do spatial mapping, if at all. And then adding this object recognition thing isn't really part of current pipelines. It's a very expensive process unless it goes against some lookup table. So if you're a search engine provider, you actually have a good chance at getting this right. Look at Google Lens, for example. So object tracking is now something that we can do, right? If we can do object recognition, we can do object tracking. So let's bring in a ping pong racket. Now we have that. And it's actually a physical one, okay? We're playing ping pong in AR now, so that's fine. Now, we actually scan this object, we recognize this object. Did you see the blue? I hope you noticed. This was tedious. Anyway, so object recognition to detect the physical object in the real world. We've scanned it, and now as the user moves it, so I'm gonna play, hit the ball, we can actually register, that means the 3D location, and track it, which means if you build this over time, we can actually determine the velocity at which you hit the ball. And now we're going to hit the ball, and the ball is going to bounce off the table. Pretty cool. Remember, it's a virtual ping pong ball. Okay, we use the physical object to hit a virtual ping pong ball that was then bouncing around, using the idea of object recognition and then also registration and tracking. Pretty cool. So these are some of the concepts that I think are pretty fundamental, but also advanced. You can build these kinds of things with displays. So obviously, with the leap motion, you could track hands that are above this field of view. So you place it on a table, has a little window. You can track your hands. You can start building some kind of more virtual controllers. I've also seen it mounted and mounted in some interesting ways and scan the hand. Now we have inbuilt hand tracking in a lot of the devices, including the Oculus Quest and obviously the HoloLens 2. Yeah, so not so important anymore. But if you want to build your custom tracking solutions, you would actually need to have a depth camera, for example, not the one that's built into the HoloLens, the InterRealSense or the Kinect I was showing off earlier. It's over there. The Kinect would also fit the bill. And then we can actually implement some of these concepts that I was just talking about. Conceptually, we could actually implement them with technologies. I do this all the time, so in a lot of my projects. And it's actually quite fun. What I don't do that much is actually custom displays, so I wanted to talk about custom displays. Along the reality-virtual reality continuum, or the mixed reality spectrum, we actually have a number of displays that we can just put out here. And so we have tangible, spatial, so projective AR. We have handheld AR. We also have head-worn AR, so it's probably somewhere here. We can have room size, so cave, VR displays, if you will, and then head-mounted VR. So it's pretty standard. So the displays that you are probably most familiar with are handheld AR, since we spent quite some time with them in this course, and then maybe head-mounted, either the cardboard or maybe some kind of Oculus or HTC Vive virtual reality headset. What you haven't thought so much about is like, where are these other kinds of displays? And so I wanted to give a few examples here. One is Lightform, which in some ways is a shout out to a research project called Room Alive from friends and colleagues at Microsoft Research. And it's now more or less like a little spin-off and a startup. So Lightform is a combination of a projector and a camera. It's like a pro cam setup, and that allows you to build spatial or projective AR experiences. Pretty cool. And then Looking Glass, maybe that's something you've come across. I haven't actually played with it myself. I've seen it in a few installations when I visited friends at Disney, or actually at Michigan we have a few people experimenting with it. Think of it as like a window. It's like kind of like a small, comes in different sizes. It's a holographic AR display. So to give you a sense of what this is, I'm going to show you a research prototype, which is a room-sized AR mirrors. Actually, this doesn't really, like monitor-based AR is somewhere here, but doing room-sized monitor-based AR, that is really interesting. So I wanted to show you my little project here, AR mirrors. It was one of my before the holidays projects. Let's build this. I just want to see how this feels. Okay, so this is me in the lab. I have screens everywhere. It's a good and bad decision because I also have writable walls, but okay, that's a different story. Anyway, on each of these screens, I actually have a Kinect. Okay, Kinect here, Kinect here. These can track me, and each of these actually show a mirror, like a virtual copy. We actually have a 3D model of my lab, a virtual copy of what I'm doing in this lab. So we can obviously then do skeletal tracking, both the easy parts, the joints that are highly visible, and then some that are harder to see for some, let's say for this display. For that display, actually these would be harder to see. And I just wanted to color code this a little bit differently. So this is how this looks when I'm like in the room. And this really now works like a mirror. As you're going towards it, it actually changes the perspective. It renders it differently. And if you do this in front of a mirror, like you're going to the left or going to the right, you actually get to see more, a better angle at what's behind you. And so this is what I wanted to mimic here. And for that, we obviously needed to create, well, it's not really a custom display technology. Like maybe you were thinking, hey, Micah, you're building your own display. I have actually done that as well with 45-degree tilt setups, Pepper's Ghost, and all this kind of stuff. Pretty cool. But it's hard to actually demonstrate this kind of stuff, and so that it looks like a cool experience for you. We want to talk about, well, the advanced topic of accessibility. Unfortunately, it's here. So let me just say, accessibility shouldn't be listed here. It shouldn't be in the advanced topics lecture. Unfortunately, it is, because it does require advanced techniques. It does require actually scene understanding. So the system really needs to perceive the world around the user and needs to understand it like a human. So it needs to know that, well, this behind me is a wall, so don't run into it. There's a shelf. There are actually different objects in there. Maybe you placed it there, and I'll help you find it. And I mean, it's not like we probably don't need that kind of support, because that's the problem with accessibility. A lot of us researchers always think we have to help the blind people, and they don't know how to navigate in the world. They know very well how to navigate in the world. It's just for environments they actually haven't seen before. That's when it's tricky. And so scene understanding would actually help, right? So you have a HoloLens on your head, and that display now, and that device now looks into the world for you and actually reads it. It may actually read it out to you. And so it's really hard to get this right, both on the tracking and understanding and sense-making kind of part, so the semantic perception part, as well as the user experience. So the system now actually needs to describe the world to the user. I think that would be really cool. We have some research proposals in the making and currently being reviewed. It would be really cool if I could get to work on this, an AR screen reader. That would be really awesome. I'm not going to talk about it in my XR research lecture, but I think it would be a really cool research project. And it would require some advanced techniques, definitely. Text input, okay? So most of the time we have a virtual keyboard. It's usually not very efficient and effective, and neither in VR nor AR. Okay, what is actually still the best way is to just use the physical keyboard. But these are not really well integrated into current experiences, so that's the problem. Physical keyboards are usually not part of the AR/VR setup. There's actually no way to really, in most VR interfaces, if you type into your keyboard, even though you run it from your computer, like with a Rift S or a Quest via Oculus Link, nope, not going to work. Unless you're in some kind of developer mode, which is pretty sad. Speech commands, yeah. Okay, you're saying, okay, you can use voice or speech recognition. Fine, cool. The problem with those is that as a user, you usually don't know what kinds of commands are available. On the HoloLens, for example, there's a difference between a dictation mode, and which is kind of like a lookup against the dictionary, speech recognition mode, or voice recognition, let's say. Well, actually, it's speech recognition and not voice. Voice would be identity. And multi-modal input would be the combination of these. So these are some of the advanced topics that I think we have to work on in the future. Virtual keyboards, I have seen many different designs and layouts. The one on the HoloLens with the mid-air tapping, I kind of find that like interesting. I still don't feel, it's much better than the HoloLens 1, so don't get me wrong, but I still don't feel very efficient. Type Racer is a game that I play sometimes, and because I'm actually really good on the physical keyboard, I usually, well not usually, but I do play it on the tablet sometimes to make it fair to my students, and I should do it on HoloLens. I'm sure I'll be the slowest, like snail, in the Type Racer game. Anyway, so we haven't really figured out text input. Now I want to talk about collaboration. Collaboration is something we are figuring out and we're getting better. Most AR experiences, at least, and also VR experiences are single user, just like you. You're a poor little person in your environment wherever you're trying it out. And you could do it co-located. So if you have a friend with you in there, it's really hard to just like share an AR or VR experience. Even though we have all the technologies, most, as I said, are still designed for single user. So the first step would be to support co-located VR and AR. What is also very interesting is do kind of like a remote setup. So now we are splitting up these people. Here on the right, we have a remote setup. And so now we're going to do collaboration between the two. Obviously, this is remote, so you need to think more about networking and different coordinates. They don't share the same physical layout. Okay, I mean, to be honest, I drew it exactly, but it's unusual that we have exact copies of the physical world. Actually, that's something we are working on right now. How do we actually address these differences between different physical worlds and then have a seamless remote collaboration? I find that very interesting. So on the conceptual level, this would be a shared session, and this would require some kind of cloud anchors and some kind of like where you actually, in each of these, you would obviously define some kind of shared origin between the coordinate systems and then exchange that information. And cloud anchors is one way to do it, at least on the AR Core platform. So I also wanted to talk about adaptive layout and customization. So as you know, most AR experiences can be classified into a tabletop, room, or world scale. So how does it work for adaptive layout? So in this case, you would have just like the cube could appear here, right? So if you have that experience and let's say we design this experience where you can move cubes around, I don't know, kind of like in Minecraft. In this case, we're adapting the content to really fit onto the tabletop. Now, if you're doing room scale, well, we can make the content larger, okay? And we can use more of the space here. We can also treat this, let's say if this is your starting scene, we're taking the scene and we're scaling it up to fit the room. This sounds trivial, and it's actually relatively easy to do, but most experiences don't even do that. Most AR experiences are designed for one of these, do not allow you to move between these. They don't ask you, are you going to do room scale or are you going to do tabletop? No, the designer or the system developer decides for you and as a user, and that's not great. If you wanted to do a world experience, a world scale experience, it actually becomes more tricky because you then need kind of like some of the collaboration part from before, because nobody has a whole read on the environment unless we share that data, the AR cloud, aka dangerous, but we'll get there. And then it could be interesting. In this case, you're entering maybe a multi-user collaborative environment. And I wanted to really just focus on layout. Did you see what we just did? We scaled up the scene, we adapted to different room sizes. And we can do this more or less automatically because like here we know that's the shape that we can register that the user wants to interact with. On our room scale, so we can scan the room, can build the spatial mesh and then adapt the content accordingly. And then it could also be interesting as you go between different rooms, how would the content, how would the interface then change and adapt? And you could do this actually user-driven, so customization. That's how I would draw the line. So this is this idea of graceful degradation. So really making it a minimum kind of experience for small. Maybe you don't have all the content, or you scale everything down. And a progressive enhancement one is like, oh, now we're actually really scaling up the content, and we're adding layers of functionality because we probably use a more powerful device as well. And we actually blow up, in some sense, the functionality and making use of this environment. So I'm thinking in terms of these two concepts because this is concepts that I'm familiar with when it comes to progressive web and responsive web design. So we're going to look at progressive XR. Here's a little case study that friends and colleagues at Mozilla did. Shout out to Blair McIntyre, really cool person. So, and they were actually going through a number of displays here and just thinking it through, like how would we actually adapt an existing interface. Let's say we are doing this kind of like XR store, an example of like you can go shopping and buy virtual objects and preview them in your space. At least in one of the modes, you can preview them in your space in AR, and in another mode, you can actually do something more in VR. So they really thought through what's the whole design space of displays that we have, and then how do the not only the layout and all these kinds of things adapt, but also obviously the interaction. Because on one device you use touch, like a smartphone, but then if you're moving to a HoloLens in AR, you're using primarily hand interactions. And then if you're doing a VR version, you probably use either a lot of controllers or you have access to hand tracking or eye tracking, and then actually work with those kinds of inputs. So it's really interesting thing to think about. How do we design interfaces that adapt to all these kinds of interaction modalities? I would say pretty advanced techniques at this stage. Maybe in a few years down the road, we just have a few kind of different templates, or we're aiming for some cascading style sheets approach applied here. Could be very interesting. The W3C WebXR specification is also going to be built out more and more to enable this in the future, and this will be very interesting for us to look at. Finally, I wanted to really talk about mixed reality capture. Maybe you have seen me throughout the second course in this XR MOOC doing this 3D sketch. So this is a mixed reality capture. Okay, we're using some kind of virtual production here, if you will. I'm actually in front of a green screen. I'm going to show you that in a second. And I'm sketching out, actually what I'm doing in this example, I'm sketching out the world, the room in which I am. Okay, so that's me. I'm the yellow guy in there. And that's where I am roughly in the world, waving at you. And I'm gonna probably sketch where the camera is. So for virtual production or mixed reality capture, we actually have to tell the camera that is capturing us where it is in the 3D world. Okay, so usually you have some kind of calibration, and there was actually extensive calibration procedure in this mixed reality live capture tool that we had here. And then once you tell the camera where it is, it can actually sync with the virtual world. And then if you have a green screen, that's the easiest way to do it. We can extract the background and fill it in with the virtual world as we do here. And so I'm actually in Tilt Brush, which is an immersive authoring tool we are using in the second course as well. If you buy it, it's not for free. And there are alternatives to it, like Google Blocks. We could have captured that way as well. Mixed reality capture is still a bit experimental. If you play around with tools like Live, in my research, I'm actually aiming to build something that would allow an instructor to go into the room, like I'm doing it here, sketch out my content or whatever, bring in any kind of virtual content into the world, and allowing my students without a headset to actually observe, or with a headset. I mean, if they want to, we also are working on modes to actually join the 3D scene with a headset or with a phone. But let's say even without a headset, right? That would be cool. Because let's face it, if you're giving a lot of demos, like I was giving so many demos in the XR MOOC, and I worked with multiple cameras, I'm also going to do a little bit of a making of later. It's hard. How do you communicate that virtual reality experience to users? Now, the whole point of virtual production in filmmaking is to just like make people believe that, wow, they were in Mandalorian, they were actually there. And actually the actors they felt like they were there because there was a volumetric capture. They had actually LED walls, so really big displays behind, not green screen, but really big displays and in real time they render the virtual world in there. And that's also pretty cool. This whole field of virtual production, mixed reality capture, I find very exciting. So if you could remove the background, please, and bring in some really cool virtual content behind me, then you would get a sense of what this looks like. And yeah, so these were all the concepts that I wanted to capture, mixed reality capture, all the concepts that I wanted to cover, advanced techniques. There's so much more to learn. And well, in a few years from now, hopefully this is like, let's do a basics rather than advanced techniques, especially accessibility. I really don't want to have to say accessibility requires advanced techniques. So let's all work together to actually make it easier for developers and designers, but also for users. Okay, so I hope somebody hears this and is interested in working on this together with me and with the community. In this segment, we're going to talk about XR research. Now, when I say research here, I'm thinking user research. Not so much academic research. So this is not like the lecture that provides an overview of all the things that happened in the XR space in various communities. There are obviously a lot of academic conferences out there, and I'm active in a few of them, but that is not the goal here. So I'm going to build this lecture around a research project that we submitted to the ACM CHI, so the main Human-Computer Interaction Conference. That project is called AMRAT, Mixed Reality Analytics Toolkit. So I'm going to build a lecture around it. But I'm going to present it very differently. This is not a paper presentation. This is not an academic research presentation. I want to use that work to reflect on what it means to be involved and to be doing XR research. So working with users, a lot of experimentation. And I'm also going to use it here at the end of this course focused on development, because that particular project allows me to cover a few topics that we haven't spent too much time on. Custom marker design, multi-user collaboration, so there's a few things there. Spatial mapping and working really with a HoloLens. We haven't spent too much time working. Obviously, these devices are still very expensive and not a lot of people have them. So it didn't make sense to have the MOOC focused on those devices. But we can learn maybe from a case study like the one that I'm going to present here. So the way I'm going to talk about XR research here is in terms of three main things. I'm going to talk about topics, we're going to talk about skills, and we're going to talk about questions. So topics, yes, I'm going to provide a little bit of an overview of the research landscape in terms of topics and my assessment going to a number of conferences over the past 5 years focused on that. Share that observation with you. We're going to talk about skills, so what does it take to participate in research? And then we're going to talk about actually what I think are good questions to ask when it comes to XR research and what are not so good questions to ask. This is not so much in terms of hot research topics, it's more like how to approach research in XR. So a little bit more general and broad. So let's start with topics. So obviously, when you zoom out, there's VR and AR. And so when you go to major conferences, what you feel like is everybody's talking about VR and nobody's really talking about AR. No, that is an exaggeration. But there still seems to be this imbalance when you go to conferences right now in 2020. Yeah, so the VR part is maturing, right? We see lots of devices out there. A lot more people can do VR. AR is, unless you're doing smartphone-based AR, it's still very expensive. Like, not everybody has a HoloLens or Magic Leap. Not everybody can do studies like the one that I'm going to present here with multiple HoloLenses. And so I feel like, yeah, it's understandable. But I hope that over the next few years, this is going to balance out. And maybe the AR is really, really hard as well. So we should really spend some time on it. And so when it comes to topics, so when I go to conferences, I hear a lot about sensing and input. It might just be that I'm going to a lot of technical conferences. It is also true. I mean, tracking is really, really good actually already, but we can always do better, especially on the sensing. When you talk about sensing, I mean, traditionally sensing and input is more like SLAM and those kinds of things. But in the next few years, and actually already, It is about really semantic scene understanding. So really making sense of what the device sees and what is around the user. So we'll see more there, I'm sure. We're also exploring applications. A lot of the vendors are actually just throwing out devices, throwing out is probably a little bit of an exaggeration, but giving out the HoloLens, for example, to Michigan, or that's mostly, I think Microsoft was a primary partner so far, for us to explore what we could do with it, and giving it to a university like Michigan, which has like so many different disciplines and schools. Is actually a smart move. So together we can then explore all kinds of applications, and you see a lot in the even in the research literature, you still see applications papers and really cool case studies there. I think prototyping, well, I put prototyping because I was working on prototyping, but also that's a space that I understand very well, and I think there's still a lot of interest. And even though I would say to a new PhD student, hey, maybe we shouldn't do prototyping, it's really hard to publish there. I do think it's still relatively unsolved. It's still very expensive and hard to create AR/VR experiences. The prototyping tools out there, they're just like doing this super basic stuff, right? They're like allowing you to design a marker-based experience without programming. I mean, really. That is cool. That is cool in some sense, right? It's like it's creating this WordPress so that everybody can write AR/VR applications. I get it. Like that's the whole power of WordPress and how it transformed the web. In fact, we've studied this a little bit. And I understand that template-based design could be a good approach to AR/VR as well. But when it comes to that, I would like to see more guidelines and more principles around ethics, for example, built into these tools. Guidelines guiding good design, that would be cool. Showing an object in AR, as I said in the very beginning of course 2, which is like the brother or sister course related to this one here. There is so much more that you need to do when you're designing an AR experience. It's not just about showing some 3D content to the user. The context really, really matters. And then human factors, like really understanding what impacts users. So motion sickness is something that, well, I did mention a few times, but we really need to do more human factors oriented studies to really understand why people feel motion sick and how we can improve it. I mean, we have a basic understanding and there's a lot of work in this space, but it's still interesting and it's not really clear how it translates in design. Design and accessibility, I hope to see more. Right now, I'm not making this smaller because I don't think it's that important. I'm just telling you this is what I'm observing, and the attention is probably shifting, hopefully, towards the more user-oriented topics. Collaboration is one that I think is a very big one and that will require actually a lot more work over the next few years. So I do think that collaboration is important through COVID-19. It was definitely emphasized, but I haven't really seen yet good collaboration applications in AR/VR. So I want to come to this question of how to contribute to XR research. So you actually do need quite a few things. I do say to my students that UX, interaction design skills would be important. In our work, we work with a lot of users, so focus on user-facing technologies really requires that you have that basic understanding. You have a training in human-computer interaction, I think is very good. Programming skills. I'm looking for programming skills usually. I say this like programming skills. An affinity towards technologies and a technical background is still often expected. Also in my own work, it's true. I mean, I can afford to work on topics that are less technical. In fact, that's actually very beneficial in the information school where I'm working at the moment. But when you do want to, for a lot of the papers that I've been working on over the last few years, there's actually quite a lot of programming involved. And then research skills. So there's a number of ways to think about research skills, but one maybe that makes it very obvious to you now, since you've worked with these technologies, they are really bleeding edge, right? Somebody says this should work this way, and then you try it out, if there is documentation, and then it doesn't work. So this research approach to working with these technologies, kind of like running it like a lab. Okay, tried this parameter, set this value, failed. Tried another version of it, failed. Found the right threshold for the tracking to really work. And this methodological approach, computational and really driven by a systematic approach, That's really what you need when you work with these technologies. They are very researchy, very early stage still, even though they've been around for many years, and documentation is often poor. And so I think, yes, so that's why I think these three sets of skills actually come together. If you're really good at some of them, then yeah, you can contribute to a team. If you can bridge these, then you're made for research. So that's pretty cool. So for the remainder of this lecture, I want to focus on a case study. This is the AMRAD crisis case study that we presented in our paper called AMRAD, the Mixed Reality Analytics Toolkit, that was published at CHI. What you see here is actually the end result in some sense. This is one of our user studies. We had a few students participate. We built two groups. We compared them a little bit. They came to our lab. This is our lab. And they were going through this prototype. And they were there was some confusion here, like how does this actually work? So you probably notice a few things. You obviously don't see what they see, but everybody's wearing a t-shirt here. We have note takers in the background. They have just figured out something, and they're commenting on the usability. They're doing think aloud, even though we didn't really instruct them to do think aloud. They're using a number of devices. It's a collaborative task. Something must be visible to them that we don't see. Obviously, it's augmented reality, so I'm going to show you what they see. They have a task. It's really important. In order for this research to be evaluated, there had to be a task. And yeah, the time it took them to leave that room, it's an escape room scenario, that was secondary. That was actually not that important. It was important a little bit, but we built in some issues along the way, some obstacles along the way. So you could leave the room too early and you may accidentally die because you're in a war zone, for example. And or when only one person was allowed to leave the room. You just saw they left the room together. So that was interesting how they bent the rules. Anyway, so that's what happens when you study with users, right? And it's interesting. So let's look a little bit more in detail what that means. So this case study I chose because it allows me to talk about four big issues. Rapid prototyping, and yeah, I'm going to show you, even in a relatively complex project like this, where the main target was the HoloLens, we went through all the stages. I'm going to share this with you. Then the HoloLens has some more specific features, the spatial mesh. I talked a lot about this when I introduced AR technologies a long time ago, so that would be course 1. If you haven't taken all 3 courses, that's where I talk about it. Spatial mapping is really cool, but we wanted to use this to the advantage, to our advantage in the experiment, and that was pretty hard. You saw probably the t-shirts. They had big randomly generated Vuforia markers on them, so we're going to talk about marker design. We actually did do custom markers. We played around with all kinds of markers. Black t-shirt, white t-shirt, even fluorescent markers. The goal was to make that room as dark as possible so that the augmentations are relatively visible and the whole experience for the students is kind of like in a crisis, maybe with some light flickering, etc. And, well, couldn't really do that because no matter which marker design we tried, you couldn't make it super dark. It does require, especially for Vuforia, it does require, obviously, some light. Marker tracking. And then multi-user, multi-device. This allows me to talk about collaboration, which I think is very important, so we're going to do that as well. So I'm going to walk you through a few of the prototypes, and I'm not going to explain so much what is actually going on and why we did it. You can read if you want. I'm going to talk to you more about the stages of prototyping. So like with any project, we did a physical prototype. I asked my students to read some of my papers and create this really cool paper prototype. And they prototyped how we're going to augment the lab here. Had some initial ideas out there. And so this is actually pretty cool. And next we did an immersive prototype. This is actually one that I created. I did this in Quill. And so I was sketching out to my students, and I asked actually each of my students to also go through the same exercise, and we had this really cool activity where we reviewed each other's prototypes. So this is mine, and I wanted the room to be transformed. There was supposed to be some fire and an escape room scenario, so we needed a door to escape, obviously. So this was already in VR, but obviously the final experience was an AR experience. So here I show you the Unity prototype. We spent a lot of time on Unity and playing with this prototype. It has a bunch of features in there. It starts the simulation, it has a countdown, windows explode. That one was hard with particle systems, etc. We have a burning building outside. We see some dead people, and here's one of our key features. These virtual windows that we created, and that was very interesting. So there's a couple of things going on here now. I'm injured in the simulation, and I'm going to come back to these virtual windows in a second. But I wanted to zoom out a little bit so that you can see this is it. Okay, how does this actually work? Well, it'll look different when you play it on HoloLens. So I'm going to talk you through it, but it's also interesting maybe for you to see how that final experience I'm going to share with you, how that was actually designed. So I'm going to fast forward a little bit. We already had a little bit of an advanced Unity prototype here with menus and all kinds of items in there. And some of these objects are virtual and some of them are obviously actual physical objects, but you can probably tell the difference. And this is a HoloLens 1 recording. In this case, we didn't have spatial mapping enabled. So this led to a lot of issues. We wanted to have a multi-user experience. We wanted to be able to perhaps choose the room in which it's going to take place. It shouldn't be hard-coded or fixed for our lab. And we knew that there will be people in the room, and they will be in the way of each other and standing in front of augmentations, and therefore occlude them. And then it look weird if they have chairs and everything shining through their bodies. So here's a prototype with spatial mapping enabled. What you can see now is that obviously we're rendering occlusion, and some of the objects are really under the table and you can only see them from certain perspectives. And you already noticed some performance issues here, and that's really the long story short, even though that vase down there is pretty cool, and the fire. I think my student Lucy is running this prototype here, and we had really cool fellow students and interns visiting us, and they are also hardworking and debugging AMRAD at this stage. And yeah, you can see how these things are coming together. Anyway, we have spatial mapping enabled here, but it leads to some issues. So one of the ideas I had was, hey, we wanted to create this really big building out there, and here's an explosion and a window explosion, and that was a really cool prototype that Shweta on the team created. So if you want to show like a big building out there, how are we going to do it with a small FOV that we have on the HoloLens? And how are we going to deal with the performance? We just noticed issues in spatial mapping. So you can never see that whole building anyway. So why don't we create virtual windows? Was an idea, and we experimented with this a little bit. It helped us address performance issues. I'm going to talk to marker design now. So we're going to switch gears from spatial mapping to marker design. I'm going to just continue my story about AMRAD, the research project. What you can see here is a combination of different kinds of wounds. Trigger warning. Maybe this is not the one that you wanted to see. Yes, so we were working with somebody from nursing, and that person was a professional, and she knew how to create those wounds. So she did it on mannequins, and some of them here we had early prototypes. It does look, well, because we didn't do it right yet, it doesn't look believable, and this is like what we call bacon. This should have been a burn. Anyway, you also see the other issue here quite clearly, that the virtual objects are not behind the person. But the focus of this video was to introduce you to the marker design. So we actually spent some time on creating our own markers, and then we did fully custom marker design, and then in the end we went for these markers because we had to build in identity into the markers. It was supposed to be a multi-user experience. But then in the end, what these markers allow us is actually to know exactly who in the simulation is injured, because again, identity is built into these markers, and we know exactly which kind of injury it is. We know the location, and then we can actually do these kinds of scenarios where we triage people. It's a multi-user, multi-device experience. So you can see these wounds both through the HoloLens and through the smartphone. And we're using Unity and Vuforia for that. And then you can go through this triage protocol and assign labels, triage labels to people. So that's pretty cool. And then when we actually do a user study, we bring participants to our lab. This is the whole core of AMRAD. What was really focused on was like collecting these events and allowing you to filter them. So it's really cool. When you obviously do research with these devices, you can collect a lot of the additional data. But then the issue is, how do you visualize the data? How do you make sense of that data? And that is still a little bit of an open question. But we did try out this in situ exploration using an additional device like the iPad and the HoloLens, and I think there are some cool opportunities. And obviously, once we collect data, we can visualize it in very interesting ways. So here you see step-by-step playback. In the center area, you actually see a timeline. It may not be exactly obvious right now. And on the right, you see a floor plan. And then we can filter these events. And anything you filter here, you can then also immediately preview on the HoloLens. So you can go back to the location where that research study was conducted and analyze it that way. So I shared a lot of the design process. It was really quick rundown. I talked about a lot of issues that we had to solve, and obviously there's more in the paper. I was able to show you some of the prototypes that we created, both regarding the world, experimenting with spatial mapping, and in the end, that story didn't finish, right? But the spatial mapping, we just had to disable it for performance reasons. But that's also why we put dead bodies outside and said to the user, stay away from the windows, right? By introducing a scenario, you can also guide that a little bit and work with one of the participants. She really went to the window, but then another participant was like, hey, you should stay away from the windows, don't get killed. And that was really interesting how our participants really then played that story, and they were really cool participants, so that was really fun. On the t-shirt side, so we couldn't get the rooms super dark. We still lost tracking quite a bit. The HoloLens was actually, we were using an older version of Unity 2017. That work was, it started in 17, but it continued until 19 and was published in 20. That's maybe the other story to be told about this research. Why did this take so long, Michael? But so with the Unity and the spatial mapping and mixed reality toolkit that we used, there were some issues. We debated whether we should update. I mean, there was the latest mixed reality toolkit was already version 2 for the HoloLens 2. And we didn't get the HoloLens 2 in time. I now have it. It's there. But it was an interesting kind of thing. Like we were developing a prototype. We had it kind of almost running, and so even had we gotten the latest HoloLens, we would probably not have switched. And I debated it heavily with my team, and we considered it too expensive to upgrade to the latest version of Unity and HoloLens. The marker tracking would have been a little bit more robust. We made experiments by the side whether Vuforia has improved. And it was interesting because we're building such a significant project over 2 years almost. That led to interesting new issues that you will not experience in your project, and that I never really had to deal with before. Now, that's the advantage of living in a research world, right? We don't have to maintain our products. That was that thought. And overall, the marker design was still very interesting to me. We experimented with fluorescent markers. I really wanted to make them shine and blink in the dark, maybe just to the device. Could we do this? Could we experiment this? There was a lot of room for experimentation. So many different ideas coming together in this research project. In the end, the focus was how we presented it, obviously, using that case study to illustrate the usage and the use of that tool, AMRAD, which allows you to collect data. And in order to be able to do more research in the future, we need tools like this. Not only collect data, but also visualize. And then when you collect data, we want to be smart and actually responsible when it comes to collecting data. One of the last issues that I dealt with a lot in that project was like, how do we illustrate these wounds to people? And we had like a comic-based version, the bacon version, and we had a more realistic version. And the whole idea was like, hey, it could be different generations of medical students using this, and then those that are more advanced, so year 4 or something, you know, they need to see something in order for them to feel like, wow, this is really a crisis. And yeah, we did not, but there's a really cool opportunity to do more research there, right? You could have different generations of students work together through that experience. Finally, whether or not our mixed reality version, and that's what I'll talk a little bit more about in the paper, whether that improved over the original classroom experience that the instructor that we were working with was using, whether that learning experience is better with mixed reality technologies, can't say yet. We have a really big XR initiative here at Michigan now to figure this out, and there is some research that gives us some pointers, but yeah, everybody seems to be targeting tiny little applications, and then, because nobody can really say whether it generally improves learning. So maybe over the next few years we will see more of this. Tools like AMRAD will probably allow us to make more progress there as well. So quite an impressive work from my students. So I wanted to thank you as well for believing in this work and doing it, continuing to do it with me until it was finally published as a best paper in the end. So that was cool. But I want to talk about good and bad questions in the context of this work and maybe our larger understanding of XR development and then also research and development. So, good and bad questions. So obviously one of the things you will ask yourself is when you engage in a new project is what has been done, what is currently possible, what are the low-hanging fruits. I still hear that question a lot. People ask me, what are the low-hanging fruits? Yeah, and I get it, why they ask it. I don't think it's a good question. So on the left, you actually see the bad questions. Okay, I should have been more explicit. So it looks like the good ones are on the left and the bad ones are on the right. No, the bad ones are on the left. Okay, so what does it take to have this? That's an okay question. I'm going to show you a better question. What is cool about it? Well, that's in some research communities, like the user interface software technologies community, WIST. That seems to be the main question to judge research. Well, no offense there. Who are we designing for? So these are, some good and bad questions, mixed. Mostly, I actually look at them on the left quite negatively. If you thought that, hey, there's nothing wrong with what are the low-hanging fruits, I'm going to show you my version of that question. So, whether something has been done, that's a really difficult question to ask in research, because you would have to read a lot to figure it out. And also, what has been done, like really establishing everything so that you can then pick your topic? No, not a good approach. So I often start with, hey, we have an idea, let's prototype this, let's see how this goes, and then we can see whether it has been done. And that is more directed research, and I think that's a better way to go about it. What is currently possible? Again, another really big and vague question, and it's also not sufficient, because like research should be long-term, right? Like it's cool that you can currently do this AR Core, AR Kit project, but what does that mean for the future of AR? And should it be mobile to begin with? So the better question is to ask, what will this enable in the future? And if that's your mindset, and then you're really inquiring about the future and not just about what is currently possible. What are the low-hanging fruits? Well, let's at least rephrase it as what are the open issues. The low-hanging fruits has this intention to solve quickly, quick and dirty, patch and fix, and I don't think that's a good way to think about research. What are the open issues though? The hot topics, fine. But really the open issues, what matters? That I think is the good way to think about it. What does it take to have this? Okay, fine. I mean, yes, I'll probably ask you this if we work together on a research project. I'll probably ask you, what does it take? But the better question is like, what if we had this? You know, you're working so hard on your prototype and then you write about what it took to create it and a few users tested it and that's super cool. Okay, fine. But did you really ask? Did you really investigate what if we had this? Did you spend enough time with the users? Was the study just designed to show that your system is cool? Or did it really answer the question like, what would we do or what could we do with it? And I think you should maybe, a lot of my papers, at least in the last few years, I've been shifting a little bit. I've been trying to do a little bit better research by asking more this way. What is cool about it? It's fine. What does it enable? Yeah, that is key, right? Does it enable something that we couldn't do before? Does it empower more people? That is a good question. Finally, who are we designing for? I think it's a good question to ask, but better is how can we design with them, right? So who we are designing for without ever talking to people. So a lot of accessibility researchers are kind of like designing for blind users, but at least that community has a standard that we don't, we do actually involve users. We don't just think we design the right thing. So think about how you can design with them rather than for them. I think these are good ways to think about research. So this was sharing a little bit my principles and how I think about XR research. Some of this is probably a little bit more generic, but I at least try to make the case how it applies to XR research. So in this second part, I want to talk more about the research topics. Okay, so AR, VR, we've seen those before. And there's a couple of topics that are kind of like being explored, and I would say we've made good progress or are still making good progress. And these are shared between AR and VR. Then we have haptics and locomotion, more VR-specific topics that are still receiving a lot of attention in research. What are good controllers, and that makes sense, and how do we actually track and move? How do you move in VR? And then safely. And on the AR side, perception. So obviously occlusion is an example that I used a lot throughout, but there are other perceptual issues with AR. So that's still both the human perception and then the computer vision parts, the scene understanding. So these are some of the big topics. So a lot of the research that you find out there, at least the ones that I read, the papers that I read, they fall into some of these categories. But I do think that I want to see more research on ethical and social concerns, on accessibility and equity, and privacy and security. Because now we actually have technologies that are used by users, not just limited to enterprise or research lab contexts. And so we really need to see more of a shift. The problem with that is that the topics, as I said, require often a very high technological knowledge. So I've been working with a few students who really think about privacy and security, but then the main question is like, how do I build my prototypes? And you still kind of need to create them, but there are prototyping techniques. So if you took some of these, if you looked at some of the lectures here, I hope this will help you, especially course 2 will help you with rapidly prototyping and approaching, and then also thinking about ethics, social concerns. So on the ethics side, so I have lectures dedicated to this. We touched on this a few times throughout the course, but we could always do better. So on the ethics side, I'm still wondering what are actually good ethics principles of XR design. So these are some of the questions you should ask yourself. What when users can't tell what's real and what's virtual? While that might be cool for your application, I don't think it's a responsible thing to do. What is the role and responsibility of the XR designer anyway, right? So my lecture on XR design ethics is something that I would recommend you revisit at least. And also, while this course was really focused on building these technologies by working with the technologies, yeah, I think our ethics thinking came too short in this course, and so let's not forget about that. Finally, I want to think about design impact. Anything and everything you do has an impact on the users of these technologies. And so it's not just like after. It's actually before users try it out. You need to set the expectations of users for this new reality that they're going to experience. During, you really have to balance realism, and I just aim for believability. You need to really optimize comfort and safety. Yeah, if you think that your XR experience needs to be super cool and you need to trade off comfort and safety, then that's actually not super cool. Finally, once people have experienced whatever it is, even here with our crisis simulation, we did do a debriefing afterwards with both the instructors and the students that actually participate in our studies. You need to help users transition back to the old reality. Now, our users didn't use it too long and weren't really fully convinced, but there could still be side effects. People react differently. And what I just said sounded pretty naive, to be honest. Right? That's not the right way to think about it. you need to build this debriefing and this returning to old reality. You need to build it in because depending on who you study with, especially children, they might, has been research where children actually mistook the virtual content or the virtual reality for the real reality. And this can happen to anybody if it's done very well, if it fakes our, if it fakes our senses, and if it tricks our senses. And so in the future, there's going to be even more dangerous, and more research will be required there as well. So this lecture enabled me to share a little bit of the research work and maybe present it differently from what's in the paper. I do think that it allowed me to talk about some of the topics in a bit more detail. Collaboration in the end didn't talk too much about it. So multi-user, multi-device collaboration was an issue. It's described in a little bit more detail in the paper. It usually comes down to networking technologies and also really how to design it. It's an advanced topic, so that requires more research. That's why I wanted to bring it in here as well in this last week. So I'm sure there's still things that we haven't covered. The intention of this lecture was to convey a little bit what it means to participate in research. And in fact, that if you're doing anything in XR, you're doing research, whether you're trained or not. And that is a responsibility that I think you should appreciate, and you should be very well aware of that. So you might make mistakes, and that's totally understandable and forgivable, but it requires the right approach. So if you're just taking this course that was focused on development, and you never really think about a lot about accessibility, ethics, and privacy and security, then that's not good. And the nature of this course didn't allow me to go that deep because we were so concerned with development. And this research lecture maybe sparked some interest in those topics. And so I invite you to look at the other courses if you haven't done so yet. And I think that would round up your technical profile that you were shaping in this course. And making you a little bit of a researcher would be super cool. A super cool side effect. All right, welcome. So in this video, I've invited a few former friends from my lab and also current friends of the lab. And so the idea is that we'll have a little bit of discussion of the kinds of XR research we've been doing here at the University of Michigan for the past 4 years. And so let's do a quick round of introduction.
Hi, I'm Max. I actually know Michael from back in Zurich in 2010 when he supervised my master's thesis. And then after my PhD, joined his lab for my postdoc in 2017 and stayed there for about roughly 2 years. And I'm now a UX manager at CNA back in Germany.
Hi, I'm Katie Lewis, and I worked at the Interaction Lab from 2017 to 2019. And I conducted my master's thesis with Michael. And now I'm a UX researcher at IBM.
I'm Ria. I just graduated from the School of Information, University of Michigan. I started working in Michael's lab my freshman year, so 2016, and worked there until I graduated 2020, and now I'll be working at Accenture as a digital consultant.
I'm Shweta. I've been working with Michael for a little over a year now. Joined his lab when I started my master's, and I'm an incoming PhD student for this fall.
Cool. So there you are. Okay, we have actually a lot to talk about. This segment is focused on XR research. So, Max and I, we have worked on a number of research projects. Is there one that you would like to highlight and maybe critique a little? What kind of research were we pushing forward with that example that you're going to give?
If I had to pick one, I'd say MRED for a couple of reasons. First of all, because it was the biggest project I participated in. I believe we had something like 14 co-authors in the end on the paper or something like that. It was also the longest project that I personally worked on. As far as I remember, the first discussions I had about MRAD were with Brian in December 2017, so that's almost 3 years ago. So that was a pretty huge project. But most importantly, I believe MRAD will be very impactful because it's a pretty fundamental thing we did there in systems research by providing, well, actually the first technical framework for usability heuristics and usability testing of mixed reality apps. And I think that's a pretty huge thing because user testing is so important in any other kind of UX design, but it wasn't there for mixed reality when we started talking about that project, and therefore I believe that the toolkit is a pretty important step forward.
Yeah, I agree. AMRAD, the Mixed Reality Analytics Toolkit, is something I've also mentioned in other parts of this MOOC. And yeah, I think maybe not the implementation in itself, but the ideas in the toolkit will live on and hopefully inform other kinds of research. I'm, like you, also proud of this project. I mean, yes, it started with discussions, and actually we had a first implementation very early on. And then it was rejected and rejected because in addition to building a toolkit, you also really have to show the value of that toolkit. So we actually, that's when we added some of the other members here. So Shweta and Ria are also co-authors, and they help with really evaluating a lot of the development work that you and Brian did early on by conducting various interviews across Michigan, and then also really doing this case study, even in a course, so MRAD Crisis. Well, it was won a best paper, so it was like worth it. I wouldn't recommend the new PhD student to work on a project, on a 3-year project with 14 co-authors is not the best.
Well, I mean, at first we thought it was more like a 6-month project, right? But
yeah, but you know, but reviewers didn't think that way. And
evaluating a toolkit for evaluation turned out to be pretty tricky.
It is true. Cool. So we've talked about MRAD. Katie, you and I, we have worked on 360 Proto, and 360 Proto is another project that is featured in the MOOC. So in the parts focused on design. Well, what can you tell us about 360 Proto? I'd like to hear your perspective.
Yeah, so 360 Proto, making interactive virtual reality and augmented reality prototypes from paper. So with this project, most of my focus was on actually creating the prototypes. So using our methodology to create, draw, build prototypes with paper. It was really exciting because I was able to kind of utilize my fine arts background to sketch a lot of the drawings, which I've found out for now in your MOOC. And use these tools to then create ways that designers can design and test AR and VR applications. It was really fun. That was my first published research paper. And yeah, it was very exciting.
Yeah, so the 360 Star Trek that you did is still one of my personal highlights. I could never have sketched it that way. And I think it's a really cool showcase. And I talk about this when we talk about paper prototyping and paper prototype testing. And we did a really cool recording in the studio where I actually walk through that Star Trek on an iPad. So it's pretty cool. So thanks for that again, Katie. Cool. So, well, Shweta, we've started working on some new research. Do you want to talk about it?
Sure. So I guess this is one of the first projects that I've worked on that I'm attempting to lead myself. And we're trying to explore AR in education, and specifically the role of paper within that space. So I think what's really interesting is that, we're trying to move towards all of these new digital tools, even XR tools, integrating them into classrooms, but paper is still a pretty constant tool that instructors and students use. So we're trying to figure out if it could be useful for note-taking, it could be useful for instructional scenarios.
Yeah, we're experimenting with a number of devices, with the latest HoloLens, with the HoloLens 2, and iPad and LiDAR, and figuring all things out. And we're getting ready for a study, which we have to conduct remotely. So some unique, well, actually, it's more like a deploying things. We're sending kits to people, design probes, so to speak. So I think it's a number of new challenges for us, but we're just adapting to the time. So this is an exciting project. Maybe we'll hear and read more about it very soon, fingers crossed. All right, so we've heard of a few examples now, which I think are really, we actually have more to talk about, but let's just have a little bit of a discussion more broadly around XR research. So if anybody of our learners is watching this and is thinking about maybe getting started with XR research, if somebody approached you, what would you say to them? Don't, or well, you should really look into this, or what kind of advice would you give to somebody who's starting out with XR research?
Yeah. No, I mean, the obvious thing would be there's huge potential, right? Not only because the technical landscape is evolving so much, but also because almost anything XR hasn't really hit the mainstream yet. So you don't have the same status there as with websites or web apps that everybody does UX design for, and that everybody does research on. So XR, even though it's been around for a while, is still a relatively fresh thing. Technology is evolving. There's pretty cool means you can use, as you already mentioned, HoloLens 2 or anything web-based. So there's huge potential in there. That's the obvious one. I'm going to start with that one.
So you would encourage people to pursue the topic. This seems like a hot topic. There's a lot of stuff we still have to figure out. That's what I'm hearing.
Absolutely. It's still pretty technical, but there's still a lot to be figured out. Yeah, and that's a pretty good start for doing some cool research, I think.
Mm-hmm.
I think I would like to add on to that. As Max says, it's technical, but I think there's also a lot of social implications and logistical implications that are really interesting to research in terms of like privacy and identity. And I feel like in terms of the data that these devices gather, there's just a lot of interesting areas that are not so technical that really need to be figured out as well.
Yeah, that's right. Design ethics, anything around privacy, and then maybe also accessibility are really big topics that I think hopefully will play an even more important role in the future. It seems when you open up the books and look into the literature, at least in the academic literature, okay, depends a little bit on discipline. So SIGGRAPH, trying to figure out some of the technical stuff. How do we track people? How do we reconstruct things in 3D? In the HCI and the human-computer interaction research area, I think the new topics are the social implications, where Katie, you and I, we have been active, and Ria as well, in some of the workshops that I think are really good, thinking about social, head-mounted display use, and then the latest one that we are organizing now at CSCW is going to be around social AR and media. So what if we go to conferences and we all wear headsets and then we see all this kind of LinkedIn information about each other? What kinds of questions would we still ask if we can see everything? We have dogs. So I don't know. So we're looking at these kinds of things at the moment. I agree. There are good topics there. Anybody else?
I think also I would encourage people to take the concepts that they're already familiar with that apply to these more 2D non-immersive interfaces, and then start asking themselves the questions of how those same concepts could apply to an immersive environment, because I think that's where a lot of the interesting research topics and the questions come up. So just picking accessibility, which Katie, I think you mentioned, a lot of people think, okay, screen readers, color contrast, things like that on a phone or a tablet or a desktop. But then how do those same accessibility topics, how would those apply in an XR interface?
Yeah. It's a really big space. I think if I zoom out, the way I would classify it is you can work on two big topics. One is making AR or VR interfaces accessible to people with impairments. I think that is in itself as a medium is not very accessible. It's a really big issue also throughout this MOOC. How do learners with impairments requirements actually participate and contribute and solve the exercises. It's been really difficult for me to think about that. The other big way to do this is thinking of, for example, AR technologies to enhance human ability. So some of the new stuff we're working on is some kind of, well, screen reader or world reader. You know what, Max, this project came, 2 years ago, we talked about this, and then I thought it was too difficult. But now we have some new collaborations with computer vision and also in biomedical engineering. So somebody really working on implants and eye prosthesis and things like that. So there might be new ways of actually looking into mixed reality technologies to enhance daily life, which I think is really, really cool. Cool. So we have covered some of the topics. Do you think there's another topic that you would like to see more research in the XR space?
What just came to my mind is things like more crossovers, like augmented reality or XR and machine learning, things like that. Like how can different types of disjunct technologies kind of like support each other and stuff like that.
So I wanted to counter you and or provide an opportunity to clarify. Yeah, so on the machine learning side, well, one thing we really have to get better at is scene understanding, right? So these AR devices, for example, are relatively good at sensing the geometry of the room, but they just don't know what the computers don't know what they're looking at. Are they looking at a chair? Yeah, maybe we're getting there. Windows, we can tell. Ceilings, floors, we can tell. Are we looking at another human? Is that a moving object? Is it potentially dangerous? Is that the kind of way you think machine learning should help, or did you have something else in mind?
No, I had nothing specific in mind, actually. I was going to ask you about like what would come to your mind when I say augmented reality and machine learning. But no, I can absolutely imagine something like that. But I mean, more generally speaking, machine learning also has like probably the same huge potential that AR has. So I believe there might be totally different ways that can pop up how machine learning could support augmented reality or virtual reality or XR in general.
Yeah, and maybe that's something else to highlight. Like, we've all worked together, and but you all have like so many different skills and expertise. And Max is somebody who has worked on machine learning. I've always been a little bit it's like I don't believe in machine learning. I mean, I use the tools now, but I'm not a machine learning researcher. I really work at the intersection of human-computer interaction as the main focus, and then augmented reality. Yeah, so these ideas, making use of these synergies of related topics like machine learning, deep learning, and deep fakes, which is dangerous, and then augmented reality or mixed reality more broadly, and how to combine these topics. Now, if you wanted to work at some of these topics, the biggest issue for me has always been that you're working at this intersection. So you need to understand user experience, design, and research, human-computer interaction, and then machine learning, and then also augmented reality, which means essentially computer graphics, and then maybe system perception or like computer vision. So if you want to master all these topics, that's really a lot to learn. It goes way beyond the things that I've covered in this course. So the only way for me to work across some of these things is by putting together a team like yourselves, like you have really interesting backgrounds and talents. So, you're all going out in this world now. You're being successful where you are. So if you were to work on the next XR project, what kinds of people would you put on your team if you had to put together a research or an XR design team?
I mean, I personally, I'm now doing e-commerce, right? Fashion retail, and while obviously mixed reality is a topic everywhere, and we might be looking into things. We're still doing mostly very traditional web development, right? So we're doing online shops, and we're also doing an app. So if I were to start a mixed reality project where I am right now, the biggest problem I would have would be how can I teach the designers I'm currently working with that really do like super traditional UX design for flat 2D websites? How can I train them to think about this whole new concept of mixed reality with all these new interactions and a third dimension. Like that they would have to unlearn some things, right? So I would totally put them on the team, and then I would have to see like how would they approach doing concepts for mixed reality. Let's just say I tell them you're not doing a website today, but you're doing a magic mirror for one of our offline stores. That would be a completely different thing. Maybe they can't use some of the methods. Maybe they can reuse some of the methods they usually use for websites. Stuff like that. Then the second thing would be you also have to bring in the developers, because we usually have a pass over from design to development at the end of the design phase, when designers just pass on the screens they've ultimately created, and developers take them and just make a website out of them, simply speaking. So what would be the deliverables there? What would a finished UX concept for mixed reality look like, and how would you specify it for the developers so that they actually know what they have to do in terms of this new mixed reality thing that is, for example, a magic mirror. So what I need on the team are really the UX designers, the people that do the concept, and also the UI designers, the people that do the screens, the developers that have to ultimately develop the thing. And then I would also try to bring in some researchers, like, well, for explaining the stuff that you're doing with Shredder now. For educating all of those people that have only worked on plain 2D websites for all of their lives, and teach them how they can transfer their skills into the mixed reality space.
Okay.
I mean, you need someone to do that, right? You can't just tell them do a magic mirror. You would need someone to explain to them how they can actually do that.
Yeah. Okay, I mean, that makes sense. So basically, the issue that you're pointing out is that it's not like we have a million XR designers to pick from. It's more like we have to figure out ways of enabling other people to transition into this space.
Yeah.
Because you don't actually have a lot of like degrees in this space yet. I mean, Michigan is working on a graded certificate program. Been teaching now for a few years, but I mean, the output in terms of talent at this stage is still relatively small.
I have an addition.
I have an addition. That's good.
So I completely agree with Max about the team structure. I feel like those things are important. I think I would also want to add someone who had a really strong understanding of data for artificial intelligence, especially if you're bringing in machine learning to your project. You really want to be very careful about the kinds of data you're gathering from your environment and from other data collection sources in your machine learning algorithm, because you want to just make sure things are safe and compliant for whatever product you're making. So it's important to have somebody that understands data and those data collectors.
So in terms of XR research, what have you learned while working in an XR lab? Like, what would you tell other people? What's it like to work on XR research?
I would say that inspiration can kind of come from unexpected places, at least looking at your past work and the kinds of things that we as a lab are getting excited about. Sometimes you bring up Iron Man as a place of inspiration, or,
Sometimes.
very often, or, The Lion King, or different movie techniques for XR director. I think even just people posting cool things on Twitter. So I think it's super important to keep a broad overview of this space and kind of be ready to get inspiration from anything around you.
Yeah, I think just like going off of that, similarly, like, because like how we were saying, it's such a new space, in a lot of ways you do have to reinvent the wheel with a lot of what you're doing, and you do need to be like imaginative in terms of how you're going to apply certain ideas or concepts or like test things, because there's not a rule book that's already been written and tested and like tried and tested. So I think that's definitely something that I've learned.
Yeah, I feel like actually one of the issues is actually evaluation. I mean, we talked about this earlier, Max, right? We talked about from a toolkit's perspective, but just like actually testing with people when the technology in itself is mostly still novel, and it's oftentimes the first time they see it. It's not like we have all these experienced AR/VR users and now we can improve their AR/VR experience. So I just find just doing research with subjects, I mean, with other humans and participants is is very tricky. We've all worked on user studies. Each of you have worked with me on a project that involved some kind of user study, and every user study was unique. Can you share some of the insights from just what it's like to work with other users on XR research?
It's interesting to see them. It's interesting and also challenging to see them like get over the learning and novelty curve of even being like confronted with this technology in the first place. Because I mean, speaking from like the experience of evaluating MRAT, like that project, you wanted to kind of just jump right into like the challenge and the procedure. But for a lot of them, like even having the headset on and like knowing how to wear it, that was the like first obstacle. So that's definitely something to like, that's interesting and to keep in mind as well.
Yeah, learning curve. I was about to say the same thing. When I think back to the 360 anywhere evaluation with the projective AR, that was pretty chaotic at first, and people didn't even really know what they were dealing with. But once they had figured it out after the first 10 minutes, everything worked really smoothly, and they all liked it a lot, and we could generate some pretty cool insights. But like the first moment people see this new technology and you tell them you have to now use this so that we can evaluate the system you're now working with, they can seem a little overwhelmed sometimes.
Yeah, it's great that you bring up 360 Anywhere. I mean, it had a different name initially. And it's actually the project that I think we did design jams around that. So as a form of evaluation, and actually Katie walked in. I think this is the first day that I met Katie. Is that true, Katie?
Yeah. Yes, that's true.
Yeah, I remember that.
So do you want to expand on that?
Okay, yes. So yeah, having experienced this initial overwhelm at like this being my first experience with any XR technology, yeah, I can agree that it takes you a second to understand what's going on.
Yeah, 360 Anywhere is actually a cool project. Like in terms of technical setup, it required a Kinect, a projector, a laptop, a phone, and maybe that phone is perhaps put in cardboard so that you can bridge physical distance and you can participate remotely in meetings. And we had these really cool ideas of annotating 360 streams. So yes, I can really see. I remember you doing the study and the design jam with people coming to the lab max and just going through all the technologies. And before the study, even making sure that we have a script and that we kind of like know what we want people to do. I think that required really a lot of setup. So it's a good example.
It was also a pretty cool study because it was so unique. The thing you said before. All the studies we did were pretty unique, so not one study was like the other.
Yeah, so maybe that's also something to get ready for. There is no formula really to XR research. The technologies are evolving, the topics are changing, and as the technologies are evolving, users are getting more accustomed to, so people have more experience. Therefore, you need less training, less priming, and you can maybe do some of the more advanced research. It also really depends on the setting where you conduct this research. So we work in a very interdisciplinary setting. Not the technical background is diverse. It's not just like computer science hackers that we work with. So I think that's both challenging, but also really cool for a lot of the research that we've been doing. So previously, a lot of our research has focused on empowering and democratizing. So empowering other people like designers and also users, democratizing the use of XR technologies. So these are really cool. There's a lot of work that we've done there. The paper max that we wrote, the What is Mixed Reality paper, I still think is, from a research perspective, it was one of those projects where it's like we didn't have to build much, right? We usually did, actually everybody in the room, we always build usually a prototype and then test it. What do people think? We have an idea, we build a prototype, we try it out. So the What is Mixed Reality research, that is actually the paper that I introduced learners to in the first course of the XR MOOC, so the one focused on the concepts. That was a little different as well. So how did you approach that research project, Max?
That one was interesting because it's essentially one of the things that I learned while working in the lab. You asked that before. So mixed reality can be pretty fuzzy sometimes and difficult to convey. And we had discussions with other people at the CHI conference in 2017 in Denver, I guess. And it seemed that everybody who was talking about mixed reality meant a different thing. Mm-hmm. So some people meant a completely different MR than what we were talking about, than what somebody else was talking about. So we essentially came up with the idea, why not look into that? Like, there is a definition of mixed reality if you stick by the Milgram paper. There's even a definition of mixed reality by the International Standardization Organization, an ISO standard. But still, it seemed that out there in the wild, people were using a whole bunch of different mixed reality definitions. So we looked into that first through a literature review to see what were research papers actually talking about. And we also did the interviews with augmented and virtual reality experts, both from academia and industry, to see how they understood this whole mixed reality topic. And then in the end, we found that there are indeed 6 distinct definitions of mixed reality that are being used. So it's really still a pretty fuzzy topic, because essentially we wrote a paper about what do people mean when they say mixed reality. And that's kind of interesting.
Yeah, it highlights this issue that when you do research in this space, you really have to be clear about what is it actually, what kind of XR. XR is even worse than mixed reality, maybe in some way, because you really know nothing about, is it AR, is it VR? Are you actually doing AR and VR? So cross reality, or is it extended reality? I feel like we should write the next paper. What is extended reality? All right, this is cool, and we could actually go on forever. We've done a number of projects and learned in each of these, as well as doing the research, also learning how to do better research, or how to do research better, which is also very interesting to me. So if you're looking into if you had to give one kind of advice to our learners, anybody starting out in this space, or also like in terms of like future XR research. Shweta, I would like to give you the floor, since you are the latest member joining the research lab in some sense, and now also entering the PhD program. So what kinds of things would you say to people starting out in the XR research space?
I'd say, I guess as a new student, probably the most difficult thing at first was everybody asking you, what are your research interests? How to actually define that. I think I really struggled with that at first. And going back to what we were saying about this being a really broad space, I think it's okay to take your time and try to build out a broad understanding before trying to become an expert in something really quickly. And I think Michael really does a good job of stressing that in his courses, and probably this MOOC as well, not really focusing on becoming a Unity expert or, really specializing in something too quickly.
Yeah, I think the whole point for me was always to have a good overview. And I try to tell people that I'm also learning about this stuff at the same time. I think it's different when, there's some veterans out in the space who have been doing XR, and Max and I, we have talked to some of them in our interviews. And it's interesting to talk to people that have been doing this for many years. But I do think it's really cool to bring in new talent. And then it's okay to say, hey, wouldn't it be cool to do this? And then I'll tell you, no, 2 years ago, there was this CHI paper. But I think even that shouldn't discourage you sometimes. Like, I feel like even though there was a research idea before, some paper before, we've had many of these discussions. In Katie's master thesis as well, we were like navigating the space, like where are we going to make some contribution? And then Ria was helping out also in Katie's master thesis as a research assistant as well in this VR project, and which ended up in this really cool workshop. And now Katie is like a leader in the space, like contributing to workshops, thinking about ethics more and privacy. I like really your contributions to a recent workshop, which I think with your permission, I'll also link to our readers, because I think it's really cool how you took the Black Mirror episodes and like this. Also, what Shweta said, this idea of getting inspiration from anything. A movie industry is interesting. It's probably the one industry. Well, there is another industry which I'm not allowed to mention here, but the movie industry is definitely exploring the XR space for virtual production, for example, something that we are also currently looking at. So it's interesting to get inspired from all these things. Well, okay, so this concludes our little discussion. One reason you're also here is I wanted to thank you, because you have contributed over many years. You've actually stayed, in the lab and contributed to a lot of these ideas, many times actually leading some of these projects as well. So this is also my thank you, because I was showing off a lot of the work that we've done together in this MOOC. Couldn't have done it alone. And that's also why you're here, in addition to sharing your research perspective. So this is my thank you to you. And so at this stage, well, I would say, let's see what the future brings in terms of new research. Wish everybody good luck, even in your, Shweta in the PhD thesis, and then Ria, Katie, and Max, turning around industry, getting them ready for XR. So thanks for all your work in that space. And I've learned a lot from working with you, which I think is also really important, that even the advisors out there, those of you who think that you know everything in this space, you don't. And it's important that you could have a student walking in, it's happened many times to me, where they have a unique perspective that's just like due to access or due to domain or a personal experience. I wouldn't underestimate that. And so I think that's actually a really important message also to you guys out there. So at this stage, I'll end before I start crying. And thanks again, everybody. Okay? And you take care of yourselves. This is the making of the XR MOOC. So in this video, I want to go a little bit behind the stage, and I want to share a little bit how we have worked on this XR MOOC, and specifically how it was, what my process was to actually capture all these demos. And obviously I had to develop a lot of stuff myself. So the XR MOOC is really a larger set of MOOCs. It's a specialization, a MOOC specialization. So it actually consists of 3 courses. And what you see here is what we internally call the detailed outline. So where we plan everything, learning goals, how we structure the modules, a combination of videos, exercises, readings, and so forth. Then obviously course production wise, I often started with filming a lot of the demos. Then I embedded them in lectures. Sometimes I did live demos during lectures, but this can be tedious for my production team. It's not always clear whether a demo was a success or not, although my facial expressions usually tell. Interviews, we did a lot of interviews and we mixed them in, and I worked on the exercises actually throughout, but really at the end, when I had most of all this done, I was really shifting back to the exercises, finishing the exercises, actually doing these exercises myself. So I added an extra week, and we were already tight on schedule, but I really wanted to do a lot of the exercises myself, recorded myself over multiple evenings, and transformed the studio, which is actually my study. And I'll talk about this multiple times throughout this MOOC, so it's been quite crazy. Collected a lot of, and produced a lot of the readings. So by readings, I actually mean a lot of the stuff that goes directly on Coursera, which is where this MOOC will launch and be hosted. So there's a lot of text and material to guide you through this specialization. And then also the quizzes. And we had drafted each of these, I would say we did like a horizontal prototype of each of these in the first 3 months, but this has been a year of work, and the final recordings here, I would say I spent 3 months almost full time locked in, thanks to COVID-19, so to say, on all this. So it's definitely been a big effort, and while I'm gonna miss it, I'm also happy it's kind of done. So what I want to do now is I want to look at a few of the sequences. I probably put together too many, and I'll tell you a little bit more about how we did them. So this is not so much about why they are there and what you can learn from them. This is really like, I mean, maybe a little bit of why I wanted it and why I wanted it to be done this way, to communicate the materials better to our learners. But the idea is to give you some inspiration for how you might be doing demos and recordings of those demos and even live demos using some of the techniques that I have, well, more or less painfully figured out while I was working on this XR MOOC specialization. So I hope this is useful. And so let's go in there and let's get started. So one of the first lectures is the What is XR lecture. And we first did a very traditional studio recording, but I already attempted to bring in all these devices to show off a little bit how they work, to discuss the concepts. So here you see me use the Oculus Quest, and I would be talking about some of the fundamental differences in terms of tracking and how things work in VR versus AR. So that was really important. So I thought it would be good to put on these headsets, for example. Just bring the headsets with you, and then also show differences between augmented reality and virtual reality. So we cut this nicely together in the studio. At this time, we were actually still working in a film studio. We still had a very professional setup, and yeah, I would do a mix of slides and then putting things on my head. So in this case, I was still working with the HoloLens 1. We were waiting for the HoloLens 2 for a long time. It finally came, and we were able to embed it in the MOOC. I actually created a few examples so that I can show off things on the HoloLens 2. I really like how we did some of these shots. It was very creative, and I thought it would be cool. So from time to time to show things behind the scenes. And then we did a few weeks later, we felt like, hey, we should do this lecture again. I think we did it like 3 times or something, I don't know. This is one where we were using mixed reality capture. I after an extensive calibration process using Live here, so Live on top of Steam VR, and then using the Oculus Rift. And what happens is we do a composition of obviously me standing in this room, and behind me is actually a green screen. You can't see that. We fill in the virtual content, and then I can sketch mid-air. And this would be a great way for students, I hope, who are not in VR to still see, and they don't have to do the mental stuff themselves. We can do the composition in this way because we have the direct mapping of the virtual and the physical world, and you see it in a really like how it should be in augmented reality in a composite view. Traditionally I would have a big screen behind me and I would show my first person view or something. So it's quite different from this calibrated camera view, and I think this works really well, but we're looking for feedback from our learners. This is how we did it, a green screen, and we calibrated this initially, so there's a little bit of setup. I did a lot of VR demos, so here is me in virtual reality. So I'm sitting in the play seat, and we are going in there. And now it was important to me that I get the switches between the camera right, so that I can show, okay, a little bit of first person, and hopefully it's okay for the viewers. Obviously I was moving a lot, because it was supposed to be immersive, and I was using all the different angles to really hopefully tell the viewers how, the learners, how this works and how the game works and what that experience is like for me. And the 360 angle is to give a little bit more of an overview of the setup and really feel like potentially for the learners to feel like they're there with me. It was really important to me. The 360 camera placement is not ideal, but it's not bad. I was a bit limited with the lights and all that, where I could put all this stuff. So then here's one of the cool demos that I did. This is not actually like the game before. This is not something I created. This is an Unreal experience, Mission AR. And what was important to me here is how I don't just capture the whole thing, I jump through it. So it's a longer story, but I wanted to have this good mix of first-person view, where you do see a little bit of black on the edges, but it's a HoloLens recording, and that black is obviously transparent due to the display technology. And it was very important to me that I can show some of this footage, and then from time to time the learners will see how I go into, how I interact with the AR content. Here I mixed in some this whole thing was actually streamed from my other computer to the computer to the HoloLens that I was using in a different room. It was an interesting setup. And then I was able to mix the Unreal Engine footage. So everything was running in the Unreal Engine, and then through holographic remoting, it was actually visible on the HoloLens. So it was basically a remote rendering on the HoloLens. And that's why you have these black outlines around these objects. Sometimes it's very visible, and I try to make it a little bit nicer by showing, for example, this is the original Unreal, what happens in the engine. This is how I see it on the HoloLens. And then from time to time, now comes my favorite scene, where Neil Armstrong actually comes out, and you can you can have him come out, so you can click this, and I wanted this interaction to happen. There was a little bit of a tracking issue for a second, but I didn't change anything in post. I just wanted it to be like that. And then he comes out, and I'll look at him, and I think during the recording for a few seconds, I actually forgot that I was recording this for the MOOC. It was just really cool. And here I played a little bit with image stabilization techniques and zooming in. So a little bit of post-production in Premiere Pro for that shot so that I get that one right. But this is then just, really, again, HoloLens footage that I show. And then after this shot, I also wanted to show the learners a little bit like how you can like obviously interact with this while I'm filming. I don't want to like do this all the time, like go close, go back, and I think my role is more like the role of a cameraman here. So you want to be stable, but then from time to time I want to jump into the role of the user, and a user would just do this, like they would go much closer. They would play with this content much more, but it is not the best way to communicate, I feel, these kinds of experiences to learners. And I wanted to end in the Unreal Engine. That was really important to me. I hope that learners will make it to the end of this video to see this and how this was actually created through holographic remoting streamed from the Unreal Engine. And that's pretty cool. And then throughout the MOOC, there will be lots of videos and animations that I created in Google Slides. Everything is created in Google Slides, and so that I can also use it in classes. Here I illustrate how the field of view works and what you actually see on HoloLens given the small degrees of freedom that you have. Sorry, the field of view in terms of 35 degrees. You do have 6 degrees of freedom, so that is obviously cool. And the photo that you see here is actually a trace done by one of my students helping me with the course design as a course design assistant, Cara Daly. She took one of the photos that we shot earlier with me in the HoloLens. So that face is actually me, believe it or not. Yeah? Yeah, I know. It is weird. Anyway, it is also fun to reveal that a little bit. This is the making of, so I should tell you some of these things, shouldn't I? This lecture, I thought I mixed things up a little bit. So I got my glasses and a beard, but that beard was obviously not grown. It wasn't real. It was supposed to be a lecture on key issues, and then the glasses are real, so I wanted to reveal this, obviously. And then I thought, hey, I need to use the snap camera to put a lens there and then disable this. And here is a very different shot where I was doing a composition. I spent this additional week, as I said, to do all the exercises in the second course, to do this Welcome to the Honors track. I wanted to see, what if I did all the steps myself? How long would it take me? Would my students learn something? I think they would. I tried this video out just recently in my residential course, and I asked the students if they had to remove some of the steps, which ones do they think are not so critical and which ones are the most critical steps. And obviously I show off a little bit of the 360 techniques that I was working on in my research. It would be important to me that people try this out. Also, several practitioners have already adopted these techniques. I did want to show the whole process, all the steps. We're actually still storyboarding, even in VR here using Google Tilt Brush. It was important to me that I show the variety of tools, not just one tool. And then, as you can see, from time to time, I go in and out to show a little bit, okay, this is what happens in virtual reality, and then this is what happens, what Michael does in what I do in the study. So as we were filming this, and I did a little bit of time lapse here and there to show things. This is actually one of my favorite videos. This was 1 week of work, and it's actually pretty long. It's 5 minutes. There's too much stuff in there. Anyway, I wanted it to feel like, okay, the learners should build the confidence that they can do this and also learn from this experience. And the fact that my sketches, like this sun here, actually looks like ice cream rather than anything super professional, that was I think a funny but useful side effect, because if everything looked like this, these are actually cutouts from paper, then maybe, and I asked students to sketch like this, then maybe that would be a little bit intimidating. And here you can see me work. We're going into the physical prototyping stage now. We're doing clay modeling here, which is something that I explored in my research that I strongly believe in, leading up to a diorama. And yeah, so I think it's also a little bit of fun. And then I actually take these things and do AR compositions with them, really taking it into this diorama stage and then mixing and merging. So this I have recorded with software that I created myself, and with some support from another student that did an independent study with me, Shweta Rajaram. And we wanted to improve my Proto AR and 360 Proto camera and capture tools. So they were previously developed by me in research, but then I wanted to refine them a little bit with students. And then we also used obviously professional tools like Reality Composer from Apple and also Adobe Aero. This one is a cool shot we did. I just put a GoPro on, and then we were in the academic innovations in one of their labs, and I'm showing off one of the prototypes on my iPad here. And I wanted to basically show this 360 prototype we just saw on paper. I wanted to show it what that experience looks like. So in the Evaluating XR Experiences lecture, this is where you can see this and hear me talk about how this is valuable and what the kind of testing we can do with these materials. And so GoPro shot. So here we're now in the third course. I'm talking about first steps, so we are going towards the end now. I do have a few shots in there that I thought I wanted to discuss. So this is on-screen capture and then using OBS, so Streamlabs OBS to live switch. So this is live, this is no post-production. This video is not edited yet. I do all this just live, using multiple cameras, but I don't even do the composition. So for me to switch from the screen capture to the GoPro, for that we have to do editing. I cannot. The using GoPro as a webcam just came out, and I wanted to try it out, but I won't be able to fit it into the MOOC. But at some stage, I think right now I have 4 cameras connected, 4 virtual cameras, a Logitech, which is up there. I mean, I can actually switch there now, so I can switch to the camera, so you see me there. Can switch to the on-screen recording. This one is currently not set up, but I can get it in a second. And then I have a game capture and a snap camera. And so all this is done kind of in live, and I'm just going to start the Logitech capture here. So you see camera, this one here, okay. And I use that a lot for like any kind of marker-based AR, so then I share the camera with the browser. Yes, we're going to access the camera. There's the camera. I bring up the marker, and we have AR working. So I can do live things, and I think this adds a lot to the learner's experience, but requires that you set up all these projects beforehand and actually then mix it in. Often I did demos before, and then I I did voiceover to these demos, so I can share these materials with my students in my residential courses. And then I embedded these videos into my lectures, and then I did another voiceover over those. I worked on a lot of concept projects, so lots of little A-frame projects like this one here to explain raycasting and hit testing. And I recorded this from 3 different perspectives, and then I put it together, but it's all recorded through a VR headset. I'm actually using the Oculus Mirror here, and I'm configuring it so that it's just showing what one of the eyes sees, the left eye, and made everything white in the background, wanted the controllers to be visible, only use a few colors, and then guide learners so that they understand the concepts. And I thought I like those videos. I obviously implemented lots of examples just to support the teaching, and those are actually available as CodePen projects. So yeah, I mean, you could show this off in your own classes if you wanted to, and maybe acknowledge this work here. A lot of technical demos, and so I'm going to go full screen here because this one needs it. This is one of the AR Core demos, and I'm showing some of the latest features here. Depth Lab had just come out. It was actually a paper we discussed at WIST, the WIST conference. Great paper actually. And so this is the related tool stack that is now being made available to Unity developers on top of the AR Core platform. What I show here is actually how depth works, depth sensing based on software-based AR. So just using AR Core, this is not Google Tango, there's no depth camera in this phone, it's just RGB camera. They're doing triangulation using VIO, so visual inertial odometry. And then these heat maps just always look so cool that I really wanted to show. And then I had recorded on screen, and so which I show here on the left, and then I just in post I just composed them and had to time sync them. This is the GoPro recording, and I thought it's good for learners to see, because they cannot always see directly what's on the screen, to have this close-up view here on the left. I do this a lot. And then I kept this as a consistent style. So a lot of examples are with the latest technology, the iPad and 4th generation, the iPad Pro with LiDAR, and the HoloLens 2, as you can see up there. They came out, and I wanted to really use both in the MOOC. We only had one iPad, so we were also doing a research project on that iPad. So Shweta, again, my student, prepared a demo that is one of the Apple demos here, and just for one day I just borrowed the iPad from her and gave it back to her the next day so that she can continue doing the research. And this is a cool little demo where you can see the LiDAR scan the mesh in the background and then the classification on top of it. And it's important to show these things and to show them live, I think, and then again captured with the GoPro, and then showing all the things where it works and where it doesn't work. That's why I mean, for example, the glass table here. There's a lot of objects in my study that are not great for AR and tracking, like the glass table, any kind of black surfaces, and some not so well lit areas. Lots of objects that nobody knows what they are because they are future generation technologies, if you will. And so obviously it doesn't get a lot of the things right. And here markerless AR. So I set up with a stand in this study, and I show occlusion here. So and really, it was hard for me to gauge, is it actually working? So I did it 3 times, I think, because I wanted the learners to have the good view and have the composition of physical, so the top part, and then what the iPad produces as I go through this virtual vase. And then at some stage, obviously, my hand should be occluding the virtual object, and it did work, and so it wasn't okay, it was a success. Finally, going more towards from handheld to head-worn AR. So here build a demo using Mixed Reality Toolkit. It's actually a toolkit that I really enjoy working with, and I have good connections to the developers, Julia Schwartz and Sophie Stelmach. They also visited my course, my residential course, well, remotely, but it's great. Anyway, so I built this demo. It shows a couple of things. It's a on-screen recording from the HoloLens with a little bit from now and then I'm going to the outside, so it was a combination of GoPro and the HoloLens app shows the mesh, and I enabled physics, and then I can start playing in the studio. It's actually, while it is conceptual and not too fancy, this is one of my favorite movies because obviously I created the software myself, I guess. I mean, I was using the Mixed Reality Toolkit, but it does show a lot of their concepts. So here's an example of an advanced techniques lecture showing a lot of the slides that I edited. This is an all-nighter because I put together all these different techniques that I always wanted to explain. I never found good explanations. Redirected walking, procedure generation, object tracking, 3D reconstruction. So registration and tracking is what I show here. So we do object recognition first. For which there are libraries that are actually out of scope. So a lot of the I did show body pics, I did show PoseNet. Well, I didn't show PoseNet, but I'm MediaPipe. I'm obviously familiar with a lot of these tracking libraries, but somewhere you had to draw the line, right? And so I show conceptually at least how registration and tracking works, how object recognition works. You can work with markers in Vuforia, you can set up model tracking in Vuforia, and so you could probably get this pedal to work. In any case, I just wanted to show that a lot of the lectures are visual without demos. They're just like slide compositions and tedious animations in Google Slides, but I think they're actually quite effective, and I'm actually proud of them. And then from time to time I mixed in some research. So here is a whole research project that we implemented. Like this idea of presenting a research paper but not presenting it as a paper, I thought was fascinating to me. So when I did the XR research lecture, I was first thinking I would give a lecture like how to do research and whatnot, but then I was thinking no, that's probably not as relevant to a lot of the learners out there. It's probably better to take a user research approach more rather than academic research approach, and then show all the prototypes, how we build the markers. You can see the t-shirts here. This is the final version of the marker design. How the demos work, how our pilot tests worked when we brought in a bunch of testers, so actually students. How some of our visualization techniques work. So this is actually some of the core part of the research, but you can explain it so that because it is, a lot of my research is very practical. And this would actually hopefully speak to practitioners, like this idea of interaction tracking, and that you can actually you know, analyze sessions, record sessions in mixed reality with some of our tools. And here was our user study, and it's cool because it includes a think aloud, and yeah, I thought this is a cool lecture and it works pretty well. And I hope that learners out there appreciate that I built in some of the research. It's obviously important to me. That's my job. I do research. I'm only like, I don't know, 30% teaching or something. The majority of my work is obviously research. So this is my long making of, but I'm going to close by just going over the film sets that we used and some of the equipment. So I'll just show everything. So initially we started out in the lecture studio. So that is with academic innovation at the University of Michigan. Has like a nice setup. They have all kinds of displays, clearboard as well, light boards even. We just used the Wacom pen and touch display most of the time. All-in-one capture solution that they have set up nicely. From time to time we moved to a green screen studio. That's where we did the mixed reality capture stuff using my lab equipment. So the Oculus Rift S. I moved my computer over into the lab of academic innovation, and we collaborated on that. Alex and I had a lot of fun, like 2 days of filming that way. Everything else, and I would say 90% of what you see in this course was recorded by me alone at home in my study with loaner equipment. So don't come here and think you will find all this. This is loaner equipment from University of Michigan. So I was using a portable home studio, which is a solution that academic innovation came up with, and that uses a relatively professional camera. That is this one. This is the Sony NX30U. That's the one. Using a GoPro, so that will be you, but we need to mix in this later. So you're the GoPro, and you're just one of two. My other one is somewhere else. I don't know where it is. It's lying over there. Yeah, I have a lot of equipment just like here around the study. I can show in. I'm definitely going to mix in one video of my bunny because I promised to the team I would do this, and I'll also show a little bit of the messy setup here. And I was using Ricoh Theta V, so that's this one here. For a lot of the recording, I mean, I used it a few times. So 360 capture, academic innovation and Alex, they have much cooler 360 cameras, but this is the one I can use at home. And this is not too expensive, and you can, if you wanted to use it in the way I used it to show off a little bit more immersively and closer, bring content closer to your learners, I think that would be the way to go. Just don't put it like in the middle, and so follow some best practices with how to position a 360 camera, which is more like somebody sitting next to you. That would be a good position. That's what I tried when I was like driving and things like that. So don't think 360 you need to put it really in the middle or something. So there are some tips here. Obviously using all these devices that are in the background, and then I put them up here next to me so I can grab them. So HoloLens 2, my latest, and in many ways also the greatest device that I have. Obviously quite expensive. Bought 2 of them, and I was able to show one of them in the MOOC, and then we did research in another one. So 2 HoloLens 2 for now. We have like 7 HoloLens 1. They were all donated from Microsoft. That was really great. But the latest ones I had to buy. Oculus Rift S. So if you feel like, I mean, I could have benefited from more support. Just to be clear, industry, if you watch this, you could have helped, made things a little easier on my research budget. But I'm fine. I'm doing okay. So don't worry. This was the Oculus Rift S, and then obviously cardboard HoloKit. The Pocket 360 is this guy. Oops, this guy here. I just think it's cool. I always take it to classes. I always have it in my backpack when I teach residentially, and then phone goes in there. And then I can do a little bit of VR and AR on the go without walking around with all the expensive things. And this is less than $15, so you could buy this and even buy this for your students. So just very quickly, I used OBS for video capture, screen capture. I actually Streamlabs OBS and OBS Studio. I used AZ Screen Recorder on the smartphone. I use SideQuest, Oculus Link, Oculus Mirror to get some of the Oculus Quest footage together, and then Oculus Mirror I used for both the Quest and the Rift S, SteamVR, Live, and Mixcast for mixed reality capture. I use Snapchat Camera for the funny key issues lecture. We use Zoom obviously for our interviews. I did do a lot of pre-production. As I said initially, I would normally do videos and demos first and embed them in my lecture. So I got better with Adobe Premiere Pro. I did even 360 cutting, which I hadn't done before, so that was fun. I did a lot of immersive authoring in Tilt Brush, Quill, Blocks, Medium, Aero, Reality Composer. These are the ones that made it. I considered additional tools. Gravity Sketch we have, for example, but I didn't show it. It costs money, and I thought I'm not actually very good with it. I didn't even show Quill in the end, I think, because I sucked at it, but I did try it out before. Anyway, I did a lot of development myself, obviously in A-Frame, CodePen, Glitch, Chrome, Firefox, Unity, Unreal, Lens Studio, Vuforia Studio, although the Vuforia Studio part was like 1 minute, to be honest. The majority of work is done in A-Frame and Unity, and then using obviously all the browser stuff here. I did play a little bit of games, so my Dirt Ready one was cool, Half-Life to show, and then I must say, from time to time, I needed a break, and I played StarCraft 2, where I became a master again, finally. And that was good. So I say to relax, but actually it was to do a little bit of competitive stuff as well. So I wanted to thank a lot of people, and what I'm going to do is I'm just going to end here and show my acknowledgements. It's a little bit of offset, I'm sure, in the video. Oh, you're looking at the cube. Hey, let me take it. Put it there. So I'm sure that not too far in the future we would be able to interact seamlessly between the physical, the living world, and the virtual that we can see here on the left. And so this is just doing a favor because people wanted to see the bunny, the one and only bunny that knows everything about XR now. She's heard everything. Okay, so congratulations. And it's so good to see you here at the end of this course. This is the course conclusion of the development-oriented course as part of the XR/MOOC specialization. This is only one of 3 courses. So this is the more technically inclined track, a way of learning about these technologies, but there is so much more, specifically in terms of trends and issues. I mean, this week we just talked about XR research and some of the advanced topics, but in some way the issues that are at hand, I've mentioned them, I've emphasized them, but we really work with them, learning about them in the first course. And then throughout the course you probably also saw a few times where I talked about design thinking, design doing, a user experience and interaction design approach. The closest to that was when I asked you to do a sketch as part of the honors track. If you haven't seen the honors track, the honors track is really a lot of the important content here. Since this is a development-oriented course, why would you take it without ever developing? So I would recommend that you do look at some of the honors track content if you haven't had the opportunity yet. So let's review what we covered in this course. Let's celebrate a little bit together the knowledge that we have acquired, and also think a little bit about what we could do with this knowledge and where to go from here after we have completed this course. So here's the course overview, and you remember this by now. I told you we're going to learn about how to approach development. We covered WebXR, Unity, and Unreal as very specific approaches in platforms specifically. And we spent a lot of time on VR and a considerable amount of time on AR. And then we also talked about special topics. So after each of these, you obviously did a quiz. Maybe the one this week is still standing out. That's fine. You can soon take it and then hopefully wrap up and make it out of here. However, if you haven't done the honors track, I would just ask you to, stick around a little bit longer. There's a lot of important content in there. It'll actually allow you to deepen each of the topics. So creating a 3D scene in one or even multiple of the platforms that we covered to really learn about them. And then with WebXR, Unity, or Unreal, develop VR scenes and develop AR scenes depending on the equipment that you have, marker-based or markerless AR, as well as 3 degrees of freedom, so 6 degrees of freedom, basic VR, or even immersive VR scenes. So there is, obviously, these are your projects, and this leads then to a peer review, and so the honors track. I really think the honors track is one of the most important components of this entire course. Obviously, the lectures, I put a lot of time and energy into preparing these lectures, and hopefully I did this right, and you feel like you learned a lot. But the honors track, that's really where you learn a lot, where you work with the learners, your fellow learners, your peers, and I hope you had a lot of interaction and really good discussion. So I started out this course and told you, what, the XR process entails really, the way I think about it, these 4 big steps. And in this course we focus mostly on development and testing. And I wasn't lying, but from time to time I obviously made references to, for example, the second course in this specialization focused on user experience and interaction design, where we really explore these other parts of the XR process. In this course, we had a lot of stuff to do just doing this, but really wanted to go deep here. So these 2 courses combined will give you the complete picture. So head over to the second course if you feel like, hey, there are still important things I would like to learn, and I would totally encourage you to do so. In this course, we focused on WebXR, Unity, and Unreal. We learned about various toolkits. These are just examples. I hope they're still around when you watch this. I thought I made good choices here, but I could be wrong. And then these were at least supposed to be popular VR and AR devices, including the webcam, which allows you to do marker-based AR. That's why we have it. And the HoloLens, AR Core, and AR Kit, these are very popular AR platforms, hopefully soon more affordable and more pervasive. And then on the VR side, I hope you had access to some of these technologies, or at least Cardboard, to work with them, or at least think about how you would develop for them. But especially in the honors track, I really hope you acquired some experience with these technologies. So this course obviously emphasized WebXR throughout. I still think it is good to keep in mind, if you haven't forgotten yet, that would be great, how this fits into the picture. So we learned obviously in week 1 how we can use WebXR as a layer on top of the web and therefore bring these experiences to the web. Obviously you're designing something very different from traditional websites and web pages. You're thinking in terms of applications, and then here's the technology stack up to A-Frame through 3JS, WebGL, and the HTML5 Canvas API, and then obviously the evolving and new, hopefully soon standard and broadly adopted WebXR specification. We learned about virtual reality content, right? All the things we need to take care of, the 3D characters of your story, the main ingredients, as I say here, and obviously that lights and shadows are required, and they add to atmosphere, and they help us establish visual cues to guide users, the environment, physics. I hope you played a little bit with physics or saw at least some of my examples where I threw cubes around in the study here, for example. I had a little bit of fun there, I must say. And then spatial sound, which I think is something that you should experience for yourself. I think it really adds to immersion. Menus and heads-up displays are clearly something that we know from a lot of movies that we have seen, including Iron Man. And so it's something to try out for yourself as well, just creating a little heads-up display. What could be this personal assistant of the future? That could be a little fun project by the side. We learned about virtual reality interactions, selection, manipulation, navigation, and menus. We learned about object placement, diegetic or non-diegetic, so in the world or world space versus screen space, so not participating in the story. We learned about what it means to place objects in the DOM, and therefore they're not visible in the 3D scene. And then we also learned about how to attach them and anchor them in other objects, for example, the virtual camera, which means that it's just in the user's gaze, the controller, or the hand. So we learned about object placement, we learned about object positioning and sizing. Really, a lot of the pain, especially in the honors track, you will really appreciate some of these statements here, these reminders. Think about if objects don't scale or rotate the way you would expect, then really something is wrong in some sense with the 3D model. If you're using multiple different 3D models from, for example, different platforms like Google Poly, they were probably done in immersive authoring tools like Blocks or Tilt Brush, and then they don't really follow clear conventions regarding their internal coordinate systems and their pivot points, and so you probably spend a lot of your time and effort in the honors track, at least, to get object positioning and sizing right. If you haven't had that experience of really building your own scenes, then trust me, this is where a lot of the issues are. We also learned about layer design. So this idea of thinking of a scene as a composition, kind of like in a movie, from foreground to midground to background, and what this means for our 3D models, for the environment, and then maybe the skybox. So visually, but then also obviously on the audio side. We also learned about iterative design. So I clearly emphasized 3D primitives and 3D models. There is a step before 3D, which is 360, and I did show some examples in this course, but also in the second course. Really, we are learning how to sketch out 360 environments, and these sketches could also be used as layers in an iterative design approach. Obviously, you could use 360 photos, which is something I showed in this course. We learned about interaction design. We learned about the differences between implicit and explicit interactions, the combination of the above, so some hybrid interactions, so mixed initiative and multi-model. We haven't implemented these, I guess, but we should not forget. The ones that you have implemented are probably mostly controller-based, so user, hand, and maybe a little bit of voice if you did it. And then if you did marker-based AR, any kind of marker or object-based recognition is something that you may have implemented. Otherwise, on the implicit side, obviously, head gaze and eye gaze is something you may have worked with. So Marker-based augmented reality, we obviously learned about marker tracking. We understand now how marker-based interactions work. We know what it means when a marker is found, when a marker is lost. We also know about extended tracking. So these are key concepts. And we have seen them in action now. We also understand more about markerless AR, how that really works, so that the system is actually choosing its own key points and then establishes tracking that way. We learned about environmental understanding. We learned that environmental understanding is obviously also a multi-layered thing. So from simple surface, so planar surface or plane detection, to spatial mapping, so really reading the environment like a 3D point cloud with depth, and this can then be used for occlusion rendering. We've learned about that. We've also learned about light estimation. Depending on the toolkits that you were choosing and the platforms that you had access to, you may have been able to play around with light estimation. Otherwise, you may have just adjusted manually some of the lights when I ask you in the honors track. Otherwise, we have learned about handheld versus head-worn AR and what it means to design for small FOVs. So field of views are limited, especially with the HoloLens 2. Form factor is still quite a limiting factor. It's such a great device, but the field of view is still rather disappointing, and this then means that you have to really adapt your design. We learned about the predominant differences between 2D and 3D content and how you can mix it on handheld, and then on head-worn you really don't have some of these options. You really have to work with interactions in front of the user, so more mid-air. So we learned about this. We also learned about the differences in tracking. Finally, I covered advanced techniques. So that was just this week, so I won't go and repeat everything. But we did learn about advanced VR and advanced AR. We also learned about accessibility, text input, a little bit at least, collaboration, adaptive layout and customization, progressive XR as a concept, and then mixed reality capture and virtual production. Some of these topics should actually be their own lectures. I do think that I will want to do that in the future. If I ever want to do a MOOC again, then I would. This is where I would start. This is where I think it would be great to actually have more content. I also think that right now these are often topics that are a little bit more researchy. Unfortunately, accessibility is still one of them, but I do hope that in the next few years, hopefully very short term, a lot of these things will be more and more available and made easier for developers, so we can make it easier on our users and we don't all have to reinvent the wheel. I think a lot of the support really needs to be at the toolkit level. Finally, we learned about contributing to XR research, what that means in terms of requirements and skills. I also talked about topics and questions. I do think that this is a valuable message that I wanted to send to students out there. If you want to participate in XR research, this is really one of the cool topics, obviously. There's a lot to be done. There's a lot on the issues side, which do not require programming skills, but rather very good UX user research skills. You can also do a lot on the UI design, so you can set an emphasis depending on your background. But almost in every project, you will need some combination of them. The skills may not be as equally distributed and as equally important, but you need to somehow balance these skills, including research skills, obviously to participate in XR research. And I hope I send the right message there. I think it's an exciting research area. I was able to share a little bit of my research throughout this MOOC and the other MOOCs, and in many ways this whole specialization has been the effort of 4 to 5 years of teaching and research, and so it's my little gift to myself as part of my tenure track experience here. Finally, this is an overview of the XR MOOC specialization. So you were in course 3, so this is the XR development course. We've covered all these topics, and we are just wrapping up the peer reviews this week. And then from here, course 1 would really focus on a lot of these issues. So the applications, concepts, technologies, and the issues really, like really spelling out the issues, ethical, social, privacy, security, accessibility, and equity are some of the really, really important classes of issues there. We also learn more about trends and how to assess trends. This will be very helpful if you stay longer or plan to stay longer in this topic. Obviously also do more on the concept side and then helping people make technological selections. This is something that you should now be feeling more and more confident in, having completed this course. And then if you were interested in deepening your design skills, I would really invite you to course 2. This one is focused on design thinking and then also doing. So you're starting with design critiques, you're doing storyboarding, physical, digital, and immersive prototyping. And we also have an honors track with a peer review there. Actually, overall, this would be a really, really well-rounded background in XR, and I really, really hope that the effort and time that I invested into this production and design, and with my team here at Michigan, that this is really a useful, a very helpful resource that is available to a lot of us for free. And I really hope that it was worth it. So please, if you feel like, hey, there are other important topics, raise them in the discussion. Maybe they are covered elsewhere and I just forgot to point you into the right direction, but I assume that by now we have quite a few learners that understand my mental model behind this MOOC, why I have this MOOC and then the other MOOCs related to this one, so it's part of this specialization, why I have designed it and structured it in this way, where we can find the relevant information. It is really quite a big set of topics and information that I try to structure in a meaningful way. So it makes me really happy that we actually have covered all these different angles in this course, the technological angle. In the first course, really the conceptual angle and learning about the issues. And in the second course, really the design focus. I do think that ideally, working in this space, you should have a good balance of all of these angles. You shouldn't just be a developer. You shouldn't just be somebody who can potentially talk about these things but not really do these things. I think the most value you would really bring to the community as an active participant in XR is if you already have this overview in this space, if you actually know about all these different angles and perspectives. At least I find it personally very valuable. I definitely started out in this area with the computer science background and the whole field of human-computer interaction. I was taking more technical topics for most of the time. And when I joined the School of Information at the University of Michigan, it really allowed me to see things a little bit differently, to think about research challenges differently, and also impact differently. And I think with the 3 courses that we have as part of this specialization, if there's just a few people out there that have that knowledge, and then this is just the starting point, there's even more after that to learn, so continue learning and contributing to this space. That would make me so happy and so proud that I have played a tiny little role in this. So yeah, that would be great. I do hope that you found a lot of this useful, that you may invite some other people to join us in this journey together. Maybe you got inspired along the way. Maybe you made the investment. Did you buy a HoloLens 2? Well, yeah, it is very expensive. But maybe as part of your work or as part of your research, if you're working in some of these communities, you have access to it. And it would be great. I'm very curious what's going to happen in the projects. So again, the honors track don't forget about the honors track. Consider participating. Look at what other people are doing. Maybe get inspired. Learn from each other. I think this should be a valuable resource, and I look forward to learning from you. It was obviously a pleasure to teach all these topics, but I always, every time I do something like this, I really learn a lot from and with my students. So yeah, thank you for taking the time to go through these topics and potentially doing the honors track. It was really nice to work with you. So, bye-bye. Well, that's great. This is the peer review. It's great to see you here. That would mean that you have done a 3D scene, a VR scene, and an AR scene, and you are ready to enter the competition, the peer review process. And it shouldn't be that competitive. A lot of us have been working very hard. I wanted to congratulate you to making it on making it to this stage. And so that's actually really, really cool. And now we are going to talk about how we are going to review each other's work. And the first thing I wanted to say is that this should be a constructive, a very comfortable learning environment. I was trying to provide a good platform for learning and exchange throughout the MOOC. And now as we are shifting some of it towards our fellow learners, please be nice to each other. I mean, it's fine to critique and provide constructive, helpful, hopefully helpful feedback, and that's cool. Sometimes it's obvious. Like sometimes if something didn't work and I'll tell you it didn't work, then there's no point in you yelling at me that I couldn't get it to work. I would appreciate much more if you told me how you got it to work. And so think of this peer review step also as a way of helping each other. Primarily, this should have happened through the forums and a lot of the galleries that we have. So hopefully, we can actually look at results and can just be astonished by what our fellow learners have been doing. So I'll walk you over this task. It is just another task. It is actually the final task in this honors track, and that's so cool. So let's look at this, what this task entails. Your XR scene peer review. So the honors track, well, consisted of these 3 steps, right? At the highest level, we created a 3D scene, a VR scene, and an AR scene. And we did all these steps here. We did probably mostly basic, but maybe even immersive VR. It depends a little bit on equipment and how much time you want to put in. A lot of the tasks were optional, so keep that in mind. And then AR-wise, I mean, I let you choose between marker-based or markerless. There was obviously the option to do both, but that's like, wow, that would be so cool. I think you would learn a lot, as I said, but it's not required. So really keep that in mind. Don't look at this table and then, like, if somebody doesn't have markerless, they only did marker-based. That is totally sufficient. That was what was asked of your peers and also of yourself. So if you did more, that is super cool, but don't expect everybody else to walk the extra mile. This is the peer review, okay? So here we're going to talk about just the peer review, and it is a task that comes with a description. So review XR prototypes submitted for peer review. So these are in a specific category. You should look at the submitted materials. These entail usually the descriptions, images, videos, not the code. If some of our learners copy-paste in some code, that is fine, but it depends how comfortable you are looking at the code. Maybe you can help them fix something, but primarily we should look at textual descriptions of what is shown in images and videos as a proof or some kind of evidence that you are working towards something. Not necessarily that it was working, but that you made considerable progress to this. You should aim to complete, obviously, each of the steps. You would learn a lot. And then you're ready to really get the best feedback. Submitting incomplete materials is not a good idea usually. It just yields often negative feedback, and I want to avoid this as much as possible. So from each other, you can learn about the development process and challenges you have had. So you need to build empathy. Okay, so understand how your peers that are asking for your review, and this is how I'm looking at this. I'm looking at how you should review other people's work. So you should build empathy towards them. They may have had challenges, there may have been technical limitations, they may not have access to a lot of the cool equipment that you may have access to. So then you write a review, and I want you to write a review in the I like, I wish, what if style. That is usually a template that we're using in more design-oriented courses, like my second course focused on AR, VR design. And so this is a very good template. You're starting with something positive. It's very, very important. And you are looking for opportunities to improve things. So you can make a wish. This should be a reasonable wish. This should be an objective thing to ask for, not a subjective thing. I wish it were blue because I like blue more than what you have is not a good I wish. And you should really include suggestions on how to get there. So, for example, if it were about the color, you could obviously provide the information on how to change the color. So that would be in the material. You create your own material in Unity. There's a few steps in the editor, and it's usually it's a best practice to have a materials folder and create materials in that folder. So that would be something that could be a concrete step where you are suggesting even how to do it. So this is the template that we're using. Definitely start with something positive, identify opportunities for improvement, explain how you would make the improvements. Don't just criticize and then don't tell and then you fail to say how you should address or how you wished somebody would address your feedback. In general, be nice, okay? So the I like, I wish, what if, we should really focus on the AR, VR scenes. If there is just the 3D scenes, that is also something you should consider. It's just harder to assess. AR, VR scenes, we have learned more specifically around the experiences, especially the user experience. And if you have the knowledge from the second course as well, which obviously would be great, you will probably be able to provide a very sophisticated, a very complete review, taking all these aspects, both the technical and the user experience, into account. And that would be a great feedback to give to learners. You should also share with them what you have learned by looking at their work. I think it is really nice to hear how, so if I get a review from somebody, they have reviewed my work and they tell me how my work helped them in their own work, that is just one of the nicest things that you can say, especially if it's true. And you should obviously review 2 to 3 prototypes is what I say here. The exact number may vary, so please refer to the final task description. You may have to balance this a little bit depending on how many projects or scenes in this case are submitted for review. But you should really do more than one, and you shouldn't do too many. So they're just like you looking at 2 to 3 prototypes. I think you would learn a lot. Doing 5 or 10 of them, then that would be an extraordinary effort, and it actually would obviously be very good for you. You can always continue reviewing things. So even when you're long done with this MOOC, can check in from time to time. Maybe the quality is going to improve the longer the MOOC is running. And so you can always come back and review some. Obviously, that would be cool, because by that time now, you should be little experts in the AR/VR space, and that's so cool. So overall, the expected results are that you have a better overview of how to create XR, so both VR and AR scenes, and then also with a variety of platforms. Even if you haven't used each of these yourself, maybe some of your fellow learners will submit materials to you that were created in Unity and Unreal, and then that way you can also learn a little bit about these other platforms, and so WebXR via A-Frame as well. So commonalities and differences between developing for VR versus AR is something that will become very clear as you're looking at these XR scenes. So our learners may choose to submit 3D, VR, and AR scenes, or also just some of them. But I hope you're getting a fair share of VR and AR experiences I hope we're not all just going to do VR and not going to give AR a try. Or I also hope that we're not just doing AR because a lot of us won't have access to a VR equipment. I do hope that we will get a good mix of AR and VR scenes so we can actually reach this learning goal of really better understanding what's the same and what's really different between AR and VR. Finally, you will obviously learn about others' development approaches and their usage of the platforms and toolkits. They can be really helpful to see how others have approached this task, where they really found good solutions, maybe what kinds of workarounds they employed, how they fixed some of the issues. So that would be really valuable learning experiences. To be honest, I often learn from the diaries that my students submit. So they submit something like you do here for peer review in my class. They write this diary mostly for themselves so that they remember issues they have encountered. And I would recommend that you do something like that too. It'll make it easier for you to go forward in the future and also track a little bit how these platforms and toolkits change over time. It's always good to have notes. So that would be valuable, and to me it's a really great resource. I learn a lot that way through the students, and when I review their assignments, I feel like I'm learning a lot that way as well. So I hope this will feel very similar to you. I want to end with a few more notes. So things to look for. So really the type of experience. So is it a 3D, an AR or VR scene? I just mentioned primarily AR, VR here. It could also be just the 3D scene. Then the question is how it would view in AR or VR. Ideally, we would see obviously the whole set of 3D, VR and AR scenes. It's just so nice to see how these scenes evolve as you're targeting different media. Whether it was done in WebXR, Unity, or Unreal, so platform and toolkit, that is something to pay attention to, how much experience you have with those. All the materials, so any written text, screenshots, or videos, you should take into account. The stage and the type of scene, so whether it's 3D, VR, or AR. Please don't comment too much on what you think was the effort that somebody has put into this scene, or what do you think is the quality. It would in any case be a best guess, and we don't know really what happened and what the struggles were unless our peers tell us the whole story. In any case, maybe you can console them if things were really not going their way, and maybe you can even provide some help. That would be ideal. How the methods were used, that is something we definitely want to look at, but we don't want to look at it in a right or wrong way. We just want to learn from our peers how they have used the methods. Maybe they have interpreted them differently than what you thought was the task, and so sometimes this can be very helpful. Also, let's look at how the tools were used. So in terms of feature selection, you could obviously suggest alternative features if you feel like, hey, there's a different way to do animations. You don't have to do it this way. You may have to use other software, or you don't have to scale models in the editor. You can do it outside in other tools. So these would be valuable suggestions. Whether or not there are explicit or implicit questions for you. So read between the lines. Maybe you can offer a hand, share your experience about or with a tool. And if there are questions about the tool, maybe you can answer them and help each other out. So novelty and creativity in how the scene was implemented. So for example, comparing it back to the sketch that was initially submitted, that sketch would be super, super helpful as a reference. So you can look at, wow, how this thing has evolved as your peers were taking it into 3D and then from there to VR and then to AR. And how just changing these modalities, I mean, it would be interesting to see how much you're adding to the original idea, just as you're getting more inspired from using and exploring your scenes in a VR and an AR. I could imagine that you come up with new ways to look at your original sketch, and that the original idea has evolved radically by the end of this exercise. So it's really like by the end of this honors track, which then really consists of all these scenes, and it's really a project. And you should take this and put it in your portfolio, and you should be proud of it. So that is really an accomplishment. Overall, I want to close by saying what I think really matters. One, fairness and respect. That is really the most important thing here. We want to be fair. We want to be nice to each other. We want to show the respect. All of us who made it in the honors track and actually decided to do the honors track in our own time and then make it that far, that is a great accomplishment. And I just want to congratulate you. And then also you should just be proud and just celebrate together a little bit. Any kind of criticism should be constructive. So follow this template. The I like, I wish, what if is a very good approach to provide critique. It's actually a standard way of doing things in design-oriented courses, and so it sets the right tone and would be great to do it this way. Treat it as a learning experience, not a teaching experience. I'm the teacher here. Kidding. No, learning from each other and supporting each other. Yes, but it's cool if you're more confident in the topics and you feel like you can share. I would encourage you to do so, but treat it as a learning experience, and so provide sufficient background and context if you are explaining things. Maybe point your fellow learners to lectures that I have given and that parts that maybe would have been crucial and then they may have missed. I mean, it's difficult to listen to somebody for a long time, so maybe we missed something, so we can help each other out in that way too. And then finally, identify opportunities for growth, both obviously in your peers, but more importantly, in yourself.